Because in
Well, the
reality,
flat
everywhere you go, the horizontal and the vertical are perpendicular, aren't they?
or the flat Earth, yes.
In reality as well.
No, not in reality. The
Yeah.
reality is what I'm showing you here for the actual Earth, for the globe Earth.
No. I'm saying, in reality, everywhere, vertical and horizontal are perpendicular.
No,
Yeah.
no.
Yeah, I've never seen anywhere in reality where vertical and horizontal aren't perpendicular.
That's because you think. That is because when you move, uh, how can I do that? I would have to do another plane. Um, when you move, you wherever you are in the center, this is what your reality is going to be, is seeing this sort of thing. And say this, I'd have to draw another picture. Here, hang on, let me draw another picture.
Yeah, well, we're decided we're backing Sean, especially with the Polaris argument. I'm not personally me. I'm not talking to anybody about Polaris unless Sean Hawkins is there. Well, how are you gonna know that the water level isn't just sloping one way?
Or can't. Well, it's impossible for an auto level where the compensator is moving freely to have a bias.
Yeah,
It
I'm
can't
saying
slope.
the water's dropping though, right? That's what you're trying to measure.
Yeah.
Yeah, so how do you know at the end, or how's Rumpus going to know at the end of the day that the water's not just dropping one way? How do you know that that slope?
If it was dropping one way, it would be flowing, wouldn't it?
Oh, yeah, here's one. Yeah, today. You know, when you're looking, you're setting your auto level up, and the horizontal that you,
Yeah.
the crosshairs, they're just at the auto level, right? That horizontal is just at the auto level, like where that. I
Yeah,
don't know
it's
where do you say the horizontal? Is it at the reticule, or is
yeah.
it sort of the horizontal at the pendulum? Where would you have
Well,
the horizontal within the?
it's all set up so that the horizontal crosshair establishes your horizontal.
Yeah, but that doesn't go all the way for 5 miles. That horizontal,
Yeah, it
does it?
does. Sure, it does.
No.
Yes, it does.
Well, all the way 5 miles horizontal.
Go 100 miles, 10,000 miles. As long as you can see in the distance, that's the horizontal.
Are you sure?
Yes, positive.
How big it would be your biggest horizontal plane that you could make?
I'm not sure what you mean.
Like
How big?
it's the auto level. As I understand it, establishes a horizontal plane of reference because you can spin it round, can't you?
Yeah, 360 degrees. You can make the whole plane if you want. You
And
like you're
that would
sitting
be an
in.
entirely horizontal plane.
Correct.
Right now, if you set up that horizontal plane, would all the perpendiculars to that horizontal plane be vertical?
Yes.
All of them.
Yes.
As in Euclidean. I'm so good to hear somebody like says that. So when we have all perpendiculars to a plane will be parallel. That you good with that, right?
Yes.
Right. Okay. And if it's a horizontal plane, then all of those perpendiculars will be vertical.
To that plane. Yes.
Yeah. Good.
but not necessarily to the Earth,
Just to the plane.
just to the planet.
Yeah, that's the Euclidean principles that we work with. That's good. It's good to hear somebody like that, George. You've definitely showed that you've got a bit of experience with these tools. Should hear what some of the people have been saying recently.
I happen to be available.
Right, sweet. Well, I was asking because we seem to think that Brian's the only contact we have with you about your test.
Yeah, I suppose he is the only flat earther that I have time for, really.
Flat earther?
He seems to. Yes.
Oh. Well, we're not flat earthers.
You're in
so
wrong place.
that doesn't really.
Yes, you are. You're a flat earther in every regard.
Pardon?
You are
Earth's not flat,
earther
Rumpus.
in every. The Earth is indeed not flat. Oh, well, yeah, God, don't please. Oh, Jesus Christ. If you start talking about hills and things, don't be a twat. We're talking about the surface of the water, you
Yes,
moron.
I've been called a twat on
You
Rumpus.
stupid twat. If you think that's, I
Rumpus.
mean, that's a sort of deflection argument that means you're just a moron. You're a moron. Yeah,
Oh.
you're a moron.
Gone fishing.
You're a moron. Yeah, you're a moron. You know that.
Right. Well,
actually,
can we?
actually, I'm not familiar
Can
with
we
you,
not?
actually. You're a new moron.
We're not do this.
Yeah, but
Like,
when some twat comes up with that point, which is something you've done as well.
What,
which is
that it's
say,
not
"Oh, look,
flat?"
there's a bump, there's a hill.
Yeah.
Yeah, we know that hills exist, you moron. But we're talking about the general shape of the Earth, the geometry of the Earth in general. And so, if you wish to just talk, let's just talk about water. Pretend you're looking at still water, whether or not that's curved. You think that's flat?
Oh, in that case, it's
You're
level,
wrong.
mate.
No.
It is indeed level, which is curved.
It's level is horizontal is what we say, Rumpus. Now that's it.
I know. And
We don't talk about the shape of the Earth. We just talk about
Yeah, but that
level.
implies. Yeah. But if you think, well, the level isn't. It's curved. And if you think it's not curved, then you're effectively a flat earther.
Okay, so
If you think that, if you think water is horizontal,
a water level is a
Then you're a
tool
flat
for
earther.
establishing a horizontal,
if
Rumpus.
you think water, which is level, is horizontal,
Rumpus,
then
please
that makes you a flat earther.
get
Then
the words right.
Let
Listen.
me finish my goddamn sentence.
Well, but you keep
If
saying
you think
just water.
Let me finish my sentence. You haven't let me finish my sentence yet.
Okay.
So, if you think water is level and you think level is horizontal, that means you think all the seas around the world are horizontal to one another. That makes you a flat earther. Finish.
Okay, Rumpus. A clarification, right? What we say is a water level is a tool for establishing a horizontal
Hold on,
plane
water
of
level, not interested
reference.
about
But
water.
Rumpus, please
Hold
let
on,
me
forget about water
finish.
level.
Rumpus, please
Oh,
let
right.
me finish. Don't interrupt.
Yeah, but you're ignoring the point I just
No,
made.
I'm just making
The
a statement, my statement, to clarify the mistakes that you made about what we
I haven't
think.
made any. No, I haven't made any.
Well, okay, let me finish then, and I will say it again, right? We say a water level is a tool for establishing a horizontal plane of reference, as are every tool called levels that are used to establish a horizontal. That's what we say.
And you also think that water is horizontal, don't you?
A water level is a tool.
Not a water
for-
level.
Yes.
Water.
Yes,
The
a
sea.
water
The
level.
sea.
I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad, naked caveman eyeball and a bubble of air, you're the reason this species is a failure, and it makes me angry. You want to experience true level? Do you? You want to experience true level? Do you?
Wow, it's so... Oh my God. Oh, Christ.
Yeah, true level, bitch. Yeah, true level, bitch. I'll go in Morty's memory and do a little...
Oh yeah, it's measurable.
You want to experience true level? Do you? true level,
Wow,
bitch.
it's so... Oh my God. Oh, Christ.
Yeah, true level, bitch.
But I love Flowerford.
My name's Rumsey.
The earth is flat.
I'll go in Morty's memory and do a little.
My name's Rumsey.
Oh, everything's crooked. Reality is poison. I want to go back. I hate this.
What's his deal?
Shh. Morty. Go to school, Summer. I'll go in Morty's memory and do a little. Yeah, true level, bitch.
That's the thing. Your vision is already being obfuscated by the spherical cap.
You want to experience true level? Do you?
Parallel lines will intersect.
Yeah, true level, bitch.
Level means curved, right?
Yeah, true level, bitch. I'll go in Morty's memory and do a little. Well,
You seem to be in charge of what I get to remember.
My name's Rumsey.
Good question.
yeah, true level, bitch.
Water is demonstrably not level.
Straight lines can curve.
You want to experience true level? Do you?
People have measured the surface of water to be curved.
Yeah, true level, bitch. Yeah, true level, bitch. Yeah, true level, bitch. Yeah, true level, bitch. True level, bitch.
No, I'm not talking about a
All right,
water
don't
level.
don't
Listen
shout.
to what I'm saying,
Okay.
you moron. You
Oh
think
my God.
water, I'm talking about
No.
water, stop talking about water levels. Water, as in sea, as in lakes, as in oceans, you think they are horizontal to one another, don't you?
They are water, right? They have tides and
Could you
waves.
please answer my question?
They
Could you please answer my question?
are
Forget
not
about the wave. Forget about the waves.
horizontal
Forget about
because
the waves.
horizontal.
Forget about the waves. Forget about the waves.
Rumpus.
I'm asking you if you wish. Ignore the waves.
Okay,
Stop deflecting.
Put the water
Answer
in
the
a
question.
tool then called
Forget
a water
about
level.
The waves. Forget about the waves. Forget about the waves. I'm asking you to consider water with no waves. Is it or is it not horizontal?
Right, getting rid of the waves would be to put the water in a contained body of its own, and then you
On a
could call
still
that
day, there are
a
no
tool
waves.
called a
Stop
water
dodging the
level.
question. Stop dodging the question. Imagine a
You can just
ocean
keep
with no
interrupting,
waves,
Rumpus.
and sometimes they don't have any waves on a very still day. I want you to tell everybody whether or not you think that's horizontal.
I'm telling people, everybody here already knows, Rumpus.
I'm asking you a question. Stop deflecting. Answer the goddamn
I am
question.
trying to be very, very specific
No, you're not.
for
You're
you, Rumpus. I
deflecting.
am.
Do you think water, when it's not got any waves on it, no tidal effects, no bores, if it was perfectly stationary, would it be horizontal?
Yes, if you put it in a tool and
There
make
we
it
go,
and
thank
use
you.
that body of water.
I'm not asking you about a tool, you twat. Stop deflecting.
Rumpus,
I'm asking you
please.
about
Can you
oceans and seas.
Stop shouting,
Right,
please.
this guy specializes in not answering questions, reasonable questions he's asked, and he thinks that if he can deflect and change the subject, he's got
I'm
away
not
with it, and I'm not going to let him get away with it. And I'm asking him whether or
You're not
not
letting
he
me get
thinks
away with
oceans,
what?
seas, and lakes, etc., are horizontal. And notice how he's not answering. And that should make you suspicious, guys, that this guy is just a deflector.
Wow.
So could you please answer the question? Do you think without waves, oceans and seas, etc., are horizontal?
I'd say like a canal body, a body of canal, a stretch
I'm
of
asked.
canal
I described the water.
in between
Oceans,
locks.
seas.
What did I
Stop. But no,
ask you
see
5
how he
seconds
won't
ago?
answer the question, guys. This is why he's a wanker. Because he will not answer
Who are you
reasonable questions. He
talking
seems
to,
to think that
Rumpus,
if he
guys?
seems to think that if he can deflect and he can get someone like me who understands how he works, he can change the subject. He can avoid the question. Notice how he's desperate to avoid the question. I don't know whether that's because he's worried about committing himself, because obviously the answer to the question, yes, is he's a flat earther, or he's just being deceptive. I can't work out whether he's being completely stupid or he's going to be deceptive. So if he could grace us with an answer to my question, when the sea has no waves and no tides, are they horizontal? No, stop. Be quiet. Don't stop trying to save him. Stop trying to save him.
Which sea doesn't have a tide, Rumpus?
I'm asking you to consider it without a tide. Now, see, you're deflecting again.
You're asking me to consider something that doesn't happen.
You're desperately trying to not answer the question. Would seas without tides and waves be horizontal?
Could we call that like a body of water, like a canal?
You see,
could you call that canal
no,
I'm
asking
tides,
the question. I'm asking the question, and stop deflecting, you little wanker. Stop deflecting,
I'm just making the missus
wanker.
some breakfast, all right? So
stop deflecting, you little wanker.
Answer
the goddamn reasonable question I'm asking. Are seas and oceans without waves and tides horizontal?
So again, that doesn't happen in real life.
You see, I'm not interested. I'm asking conceptually. We all know in real life there are little changes and irregularities we have to go with. But as a model, I want to know whether conceptually, without waves and tides, whether or not Bev thinks that oceans and seas and any body of water connected to them are horizontal. And he won't
mate,
answer.
he's trying to tell you that
Stop saving him!
Happen.
Shut up! Stop trying to save him from answering the question.
He's not
Bev,
here.
He's not here.
Didn't
Okay,
you hear
well,
that he left for a few minutes? Oh my fuck.
No, I didn't hear
You're
that.
literally shouting at the wall right now.
Yeah. Okay, well, that's fine. I don't mind. Well, obviously, I'm just highlighting to anybody that's listening, this is the tactic that Bev tries. He avoids difficult questions because I think at some level he knows he's talking bollocks. But it could be just that he's just got this cognitive dissonance. He sort of knows that he's speaking illogically, but he's not confident in what he's saying, so he always deflects from awkward questions, and he's doing it again.
No,
now not only has he deflected, he's run away. And this is typical Bev thinking.
He's coming back, he's making fucking breakfast,
well, okay,
come on.
We'll see if he can answer a question then. Because he doesn't usually do so. Well, he's demonstrated so far that he doesn't. He wants to change and deflect.
He doesn't
and it's a really obnoxious, deceitful, dishonest way of interacting with people.
Mate, he has 7-hour videos uploaded to YouTube. Why are you lying like that?
What?
That he doesn't answer questions.
What's 7 hours? So you're telling me anybody who produces a 7-hour video on YouTube is telling the truth? Is that what you're saying? Moron.
See, you're twisting what I'm actually saying.
Well, see, how is it relevant? How is it relevant that he's uploaded a 7-hour video? What's that got to do with the price of fish?
That he's talking to people for 7 hours, for example, or
Who
3
cares?
hours, or 4
I'm asking him.
hours.
So you're saying, so if I talk to someone for 7 hours, I don't have to answer questions. Is that what you're saying? He's justified in not answering a simple question because he uploaded a 7-hour video. You are a moron.
That's what you heard of what I said. Wow.
Why did you bring up the subject of him uploading a 7-hour video as a defense for him not answering the question? What are you talking about, you moron?
Because he is.
Why are you deflecting?
Those videos.
You're following in his footsteps. You have to emulate the moron by deflecting the same way. You bring in a load of red herrings and attempt. You're deflecting from the issue. I don't know why you think that bringing up him having recorded a 7-hour video has got anything to do with the fact that he's not asking a simple question.
Do you have a mental breakdown? Or what?
No, I'm just fed up with morons and twats like you. Who, I mean, I don't mind flat earthers, and I mean that's the reason I like Brian. Is that although he was a flat earther, he engages honestly. Honestly. He tries to answer the question. He doesn't deflect.
Please repeat. What did you call me?
Like you're trying to do, and like Bev tries to do.
Again, what did you call me 5 seconds ago?
A twat. Yeah, twat.
A twat. That's it.
A twat.
You come in and calling names, whoever you want to, right?
Yes.
Because you don't know the person, and you think I cannot provide anything for what I said.
Absolutely.
Because you cut in every 2 seconds. So the 7-hour videos that I'm talking about are full of answers from Bev. to the other person.
Well, I'm not interested in the. I'm not in. I'm asking him a particular question, and he's not answering. The fact that he may have a video in which he may, I don't believe he'll answer that question. I do not believe embedded in that. I do not believe embedded in that 7-hour video is an answer to my question. Why can't he answer my question now when I'm asking it?
What I'm hearing is that he's trying to be precise, and when you ask someone that is
no,
the
he's not. I'm defining the question.
Whole body of water of the ocean is flat, it cannot be flat because it never was flat, because it never was in equilibrium. Ever.
You're saying it's not in equilibrium. You're saying it's not
in
equilibrium.
Get that? No, it's moving all the fucking time.
You're making a claim that the ocean is not in equilibrium.
Mate, the surface of that water is not flat ever, never has been.
Yes, you're just talking about waves, you moron. I'm asking about the overall general shape. I'm not asking about little wiggles due to waves. I'm asking whether he thinks if we eliminated the waves and tides, whether or not, don't call me mate, whether or not that is horizontal. And he's dodging the question. And he's doing so because it's an awkward question
then it's
for him.
Not flat. It's that easy. If it's not flat, then it's not flat.
You're saying even without the waves and everything else, it's not flat. So it's got
what without? When did you ever see an ocean without the waves?
I'm asking you to eliminate the waves as an option so we can talk about the geometry.
You want to eliminate reality
You're
or what?
You're a moron. If you can't consider the overall shape of something without the wiggles.
What overall shape? What do you even mean by overall shape?
I'm asking you about the overall shape, and on the spherical Earth.
And I'm asking you, please define what does overall shape mean.
It's spherical. Spherical, you moron. Spherical. And he seems to be saying that it's horizontal.
What does overall shape mean for you? Please define it. In general.
The overall geometry of the oceans are spherical.
No. I'm asking for a definition of the overall shape.
I've just given you one.
What does it mean?
I'm
not asking for an example.
The overall geometry of the surface of the oceans is spherical.
What does the word overall shape mean?
The geometry where there are oceans forms, if you just ignore the land bits in between them, every part of an ocean. You're a moron.
Clearly is out of his mind.
You're a moron. Just don't. Yeah, you see, you're deflecting. I mean, a child.
No, I'm asking a simple question, and you're giving an example.
I'm giving you a simple answer. I'm giving you a simple answer.
No,
the geometry of the
you're
oceans
giving me an example
on the Earth are spherical. It's very simple.
I'm asking for the definition of overall shape for whatever you're talking about.
Well, if you imagine a football or a basketball, and then I put a little blob of blue tack on one of it, you would still say the overall geometry of that basketball is spherical, wouldn't you? Now, do you understand that? So if you understand that, then you should understand. Then you should understand that the overall geometry of the oceans, etc., is spherical. Now, obviously, we've got bodies of land that form areas where the oceans don't exist, but the geometry of the oceans is spherical.
I'm trying to tell you that he is just trying to be very precise. And you're cutting in every second. Do you afraid of me? Are you afraid of me?
I'm afraid of your idiocy, yes.
Are you also afraid of me?
You're afraid of your idiocy. I might get caught to catch some of it.
You're cutting in every second that I'm trying to talk. Are you afraid of me that much?
If you raise a question about you don't understand when I say that the geometry of the oceans are spherical...
Mate, I was asking for a definition and you were giving me examples.
And you seem to have... I'm giving examples because you seem to be having trouble understanding these simple concepts. A 5-year-old can understand what I'm saying.
I was asking for a definition and you were giving me examples. Who is the idiot, you or me?
I suspect that everybody else in this panel understood what I meant. And if you've got a problem with it, then we can't even begin to have a discussion if you can't understand concepts like...
Okay, I'm back. I see you've got on with Rumpus. You've got a nice meet and greet. We got all that all over and done with. You got all your little things sorted about with.
Answer my question, Bev.
What question? Sorry, I've just come back, Rumpus.
Oh my god.
Do you want to
here we go.
Do you want to fill
the geometry, what do you believe to be the geometry of the ocean?
Euclidean geometry. That's the geometry I use.
Do you believe it to be flat? Do you believe it to be horizontal, or do you believe it to be curved?
Euclidean geometry, Rumpus. Specifically, Euclidean. Three-dimensional
Yes, because
Euclidean geometry, like everybody uses.
So how
That's
about
the
not
geometry
deflecting?
I use.
How about yes? And do you believe that the seas and oceans form a horizontal plane or not?
The seas and the oceans are a fluid body of water that are never
are they horizontal? I'm asking about the
rest.
geometry of
The
these
hydrostatics are never at equilibrium ever. So you can't base anything on the seas and oceans, Rumpus.
Yes, you can. So in other words, you're saying you don't know what the geometry of the seas and oceans are. Is that your position?
Yeah, I haven't got a clue. I don't know anything about the seas and oceans other than it's seawater. The tides go up and down, and we have a mean sea level
I shouldn't have mentioned
issued
tides.
from.
It's given you an opportunity. I've unfortunately given you a means
Rumpus,
to deflect
please. I mean,
by mentioning tides.
No,
you please.
We just
Stop
came
being
in
a
here.
wanker
You
and
called
just
us. You called us a flat earther. I asked you to clarify it.
Tides, and then you bring up the subject of tides. I told you consider the situation without tides and waves. And you refuse to answer.
The ocean and the seas have tides, Rumpus.
You deflect and deflect and deflect because you don't like having to think about these things, or you know that it's a really awkward question. And you still haven't answered my question. And don't bring up the subject of tides and waves. I'm asking you to consider the surface of the seas and oceans without them. And now you've latched onto the fact that I mentioned tides. And so you're now using that as an excuse not to answer my question. We can all see this. It's a transparent tactic. You're being a wanker. You're being deceitful. How about for once answering the question honestly? Do you believe that the oceans and seas, the surface of them, in the case where there are no waves, forms a flat plane?
Isn't it weird that Brian's lad came round and then Rumpus came round and Brian's
You cannot honestly engage, can you? You cannot honestly engage. You just deflect. Every time you get an awkward question, you deflect. You're an utter wanker. You really are. You're not an honest engager. Brian, I may not agree with him. He's a flat earther, but at least he tries to engage honestly. He tries to answer honestly questions he's asked.
Can we just leave the flat earth tag alone, right?
No.
And then can you go on to explain your test for us, please,
I'm not going to let you get away with it. I'm not going to let you get away with it.
Listen to the
No, I'm not going to let
the names you want to call people, Rumpus, are irrelevant to your test, right? Can we just forget about the names you want to call people?
No, we can't.
And continue to your test. Please.
Until you answer my question, I'm not going to describe my test.
And you don't think I've answered your question already?
No.
With extra clarity? Or not?
Well, okay, actually, you did say you didn't have any idea, I suppose. I suppose one could regard that as an answer. You have no idea.
You weren't listening. You weren't listening. You were just talking all over.
That's good.
That's
let's just say we haven't got an idea on what shape the water is with the waves or in any theoretical thing that you want to imagine.
Without the waves.
Yeah.
Without the waves.
But that's theoretical, Rumpus. I can't do that.
Yes, I'm asking you theoretically, I'm asking you theoretically,
Rumpus,
without the waves and the tides, what shape would the water be?
I can't do that. I know what the tide is like at the sea. I don't know what imagination you're going to, what you think would happen if something that did happen doesn't happen.
Imagine it's still water then.
A canal.
Imagine the tide at still water.
A canal.
Still water.
A canal.
Still water.
Can we go to a canal?
A canal would do.
Right, okay, brilliant.
A canal has the same...
A body of water in between locks, a canal. Let's talk about that.
Okay, let's imagine I made this canal 2,000 miles long.
Just make it 27 miles long in between locks.
No! Let's make it 1,000 miles long. What shape would it be on the surface of it?
Just go for 27 miles.
No, I want 2,000 miles. The question on the table is what shape would the water be in a canal, the geometry of it, over 2,000 miles? Go ahead.
A water level would be horizontal.
I'm not asking about a water level, you wanker. I asked you about a canal 2,000 miles long. Answer the question.
The water level in that canal...
Okay, sorry. Actually, that was unfair of me. Yes, you were talking about... Sorry, okay, I take that back, that last point. Carry on, sorry. Go ahead. You were actually answering my question. Apologies. Carry on. But you're just deflecting so much. You just you've lowered
I'm glad
the
you've
bar.
calmed down a little bit now, Rumpus.
Go
That's
ahead.
nice.
Go ahead. Answer
You've
the
got
question.
it out of the
So
way.
the water level.
Keep calm.
The water
Keep
level
calm.
in that 2,000-mile canal. What shape does it have?
What shape?
Mile water level.
Oh my God! Is it horizontal?
Yes.
Or is it
the
curved?
water level in the canal would be horizontal.
It's 2,000 miles long.
If it's 2,000, like, you make a water level. You show me that water level, right?
I'm not making a water level. I've got a canal. Stop talking about water
You've
level.
got a canal.
Unless you're talking about the
Canal
water level
is the
in the
water
canal.
level.
Yeah, the canal is the
No,
water
he
level.
didn't. No, he
That would
started
become
talking about water level as an
that
instrument
would become the tool.
I'm asking
the
you
device.
about the shape of the water in a canal. Forget the device. Forget the device. I want to know what shape, what geometry the water level of the surface of a canal 2,000 miles long is. Please answer and tell everybody in this panel.
The shape, the top of the water in the canal would be horizontal. The rest of the shape of the water would be canal shaped. Because the water...
Right, we got there in the end. So you believe that... Right, so 2,000
we
miles
got there in the end,
horizontal
Rumpus.
water.
I said that at the
You
beginning.
No, but that's
yes,
the same
I did.
thing. If I connected that canal to the sea, then the same... I could say that went into the sea. Exactly the same thing would occur if you ignored waves.
Like the
When you have
Suez...
little waves in a
like
canal.
the Suez Canal. See, from sea to sea, a canal in between, yeah?
Yes. Okay.
Right, okay. Yeah, like that canal.
So you seem to... We finally got there that you believe water is horizontal. And if you do to extend that,
a water
then the
level
Earth has to be horizontal.
Water level.
Yes, the water level.
Yep.
The water level is horizontal, you're saying. And if the banks of the area around that water, the canal's 2,000 miles, I'm now going to make that canal 25,000 miles long. Therefore, presumably, as you've said, it's
you can extend it. Show it.
Hold on.
If you show a shared straight line segment, yeah, you can.
Nearly there. You described a 2,000-mile canal surface water level as horizontal. If I made it 25,000 miles, I'd have to extend it, so that would still be horizontal. Therefore, you believe in a flat Earth. Because if I connected that canal and I made it at sea level at a particular moment in tide, still water at tide, then that would join the sea perfectly, and therefore the whole of the water around the world, as far as you're concerned, is horizontal. That makes you a flat earther.
So you say, so you say, Rumpus, that anyone who says that a water level tool that establishes a horizontal plane of reference is a flat earther, right?
I didn't talk about a tool. No, I didn't say that at all. You just made that up. I mean, I don't know whether
the water level then.
So stupid, didn't
if anyone, all right, okay, then wait a minute, Rumpus, wait a minute. Let me clarify then. Don't try and misrepresent me. I will try and represent it again. Okay, then I will then clarify, Rumpus. You say, okay, you say.
I talked about canals.
Okay,
and
right.
You said I said something about water levels.
Okay, let me clarify then, Rumpus.
Just stop. No, I only mentioned water levels.
Let me clarify then.
Them. I said not to mention them.
Okay, let me clarify, Rumpus, please. That you think that anyone that says a body of water within a canal from lock to lock is horizontal, they are flat earthers, right?
Correct.
Okay, that's good. It's good to know. Right, so can we get round to your test now?
Yes, okay.
Okay. So what is it you're doing with your test? What's the purpose of it?
To show drop.
To show drop?
Determine the radius of the Earth.
Oh, right. Because anybody that says that water level in that canal is a horizontal plane, they're flat earthers, and that's definitely not you. So you're not saying that the water in that canal at Bedford is horizontal, right? You're saying there is a drop.
Correct.
A drop from which end?
No, right, hold on here. This is where you don't understand what the word drop means, and this is a common problem with flat earthers. The word drop is used to refer to the drop, the distance between a horizontal and the curvature of the Earth. That's drop. We're not talking about a drop in elevation. So there are two things here.
That's how you measure elevation changes, Rumpus.
Listen. There are two sorts of drop here. One, which I don't know whether you're too stupid to understand the difference, but I'm going to explain it again. Drop when we talk about drop in the environmental geometry, we talk about drop from the horizontal. Sometimes people call drop as being a change in elevation. So, for instance, if I go from standing on some stairs and I drop down onto the floor, they say you've dropped, but that's a change in elevation. That's not the drop we're talking about. Both ends of the canal are at the same elevation. Same elevation. So the elevation's not changed. But when we talk about drop, we're talking about taking a tangent from one point, and I'm sure I'll show you a diagram. Let me show you a diagram what we're talking about when drop, because I don't know, as I say, whether you're too stupid to understand or whether you're willfully misrepresenting yourself. Let me just see if I've got a diagram here. Hold on a second.
Okay, so these two different types of drop. I mean, I know about the one that can be measured with the tool called a level, and we call that an elevation change, right? A measured drop from the horizontal.
That is drop. That's not an elevation change.
Or a change in elevation, because you measure on the measuring rod, don't you? And it goes up and down. So that's a rise and fall.
Yes,
a difference in the vertical.
Yes, that's that. Well, don't call that a drop. That's not the drop we're referring to.
That's an elevation change, right? So we get a tool called a level that establishes a horizontal plane, and we measure a vertical change of the land using that horizontal as a reference.
Right. Okay, I've got a diagram. Hold on. Let me just make sure we all know what we're talking about. So let's go.
I'm just trying to get. I understand how the surveying process
I'm just
works.
Selecting a screen. I'll be with you in a second.
Yeah.
Hold on. Give me a moment.
Well, it's okay. Well, it's all right. I'll talk amongst all of the other guys, right?
Right.
So
okay. I now have a diagram.
We know. Sorry, Rumpus. No, sorry, Rumpus. Rumpus, please. We're just trying to catch everybody else up here, right? Now, everybody in this server knows that an elevation change is measured from a tool called a level, auto level, or I say water level, but Rumpus doesn't. So that tool, you can measure an elevation change because it establishes a horizontal plane with crosshairs. You can then put a measuring rod in those crosshairs and measure the number on the crosshairs. It goes up and down as you move around the area. So you measure an elevation change of the land through the tool. That's the drop and rise elevation change that I know about, Rumpus.
Yes,
right?
But you have to also allow for the curvature of the Earth.
I've heard Jesse Kozlowski say that the water level drops from the horizontal at a rate, right? So that drop.
Yes.
But you're saying they're different drops than the elevation, right?
No, if you look at my screen, I'll be explaining you what the Jesse Kozlowski drop is.
Oh, the Jesse Kozlowski drop. Wait a minute, I've still got blobs.
The same drop. Well, you referred to it as Jesse Kozlowski, so I'm just.
No, I called it the Nutsack Drop. Actually, the Kozlowski Nutsack Drop.
Garbled. So here we go. Here's the
diagram. George did this as well. Right, I've got you on screen.
Yes, George has done something similar. So here we have. This is the definition of drop.
Okay.
I've got it on the screen. Here's the diagram.
Drop from horizontal, though, right?
Correct.
Right. Correct. So where's the horizontal there?
From horizontal. Sorry.
Where's the horizontal?
The horizontal is this. The horizontal is this purple line.
Runs from left to right across the page.
So this is it. That's
the mathematical definition of horizontal, Rumpus. That's at an angle, right?
No, it's not. No, it's not.
It is at an angle, yeah, of course it is.
No, this is horizontal. This is horizontal to this point here. This point.
That's not horizontal, Rumpus. Sorry.
There it is horizontal. This is your fundamental.
You want to imagine that's a horizontal, right?
That is a horizontal. To this point on here, because horizontal.
It's at an angle, Rumpus. Anyone here will be able to tell you that is at an angle. They would use the horizontal to measure the angle that is off horizontal.
This is because you don't understand what horizontal means. There's no mention of horizontal except in terms of pieces of paper.
Go on, please tell us what. Please tell us what horizontal is.
Let me finish my point. Let me finish my point. Horizontal is defined by gravity. That is, it's a tangent. Sorry, it's a
Defined.
tangent to the
As
surface
in
of
a
the Earth, which is-
definition.
can I finish my point? Can I finish?
Yeah.
A vertical. So, for instance, here we have up. This is vertical. This is what you would down. So if you had a plumb bob, it would be pointing down towards the center of the Earth.
No.
Perpendicular to that is your local horizontal.
Yeah.
So let me show you a number of in fact, let's go to the very front of this.
Can you just give us your definition of horizontal, please?
90 degrees to vertical.
Okay.
And I've got it here.
Parallel to the plane of the horizon, or running from left to right across the page?
No, nothing to do with horizon. Nothing to do with horizon. You made that up. You don't understand.
It's a mathematical definition of the word horizontal.
Nothing to do with the horizon. It's nothing to do with the
horizon.
horizon.
It is, Rumpus. I'm not.
Of the word,
I'm gonna stop doing this because Rumpus.
The etymology of the word.
I'm asking you.
I know you don't like this diagram, do you?
I'm asking,
you don't like this diagram. I know this is the diagram you refuse to look at, and you always run away from it. I know that.
It's on the fucking screen, Rumpus.
Yeah, but you're about to run away from the consequences.
No, I'm asking you. I'm going to ask you, right? What relevance does this have for your test that you're doing?
Because it describes what drop is. Because it describes the previous diagram I showed you about what drop is, and you don't understand.
Have you got quite a while for this presentation, then, Rumpus? Is that what you're doing? You're giving us your presentation for your test, right? Okay.
No, I'm not. I'm not just trying to give you a long. No,
off you go, Rumpus. I'll give you the mic and the floor. Please continue with your test.
Okay. Right. So here, this is the diagram that Bev refuses to look at, or maybe looking for the first time now. This shows you what vertical.
The one on screen.
Right. Now, if the one on screen, hopefully, great. So if you are a flat earther, you may disagree with it. But Bev doesn't even seem to understand what the globe model entails. So even if you disagree with it, you at least have to accept that this is what the globe model entails and what it prescribes. And that is that down, obviously we're living on a sphere, and down is towards the center of the Earth. So if I take a point here, for instance, if you can see my point, I'll put a little star here in yellow or something to show just make sure you know where I am. Let's take that point there. Let's give it a letter. That'll make it easier. So let's take this point here. Oh, bastard. I can't put it on top of that. Okay, hold on. Sorry, I'm going to have to go inside these.
Do you always have to put this bit in as a part of the routine?
Yeah.
When do we get to your slides for your test?
Because hold on. This is the bit you need to understand what the hell's going on.
A circle.
Right,
We've got it. Everybody's seen this picture millions of times before, Rumpus.
Well, apparently you've avoided it on many occasions. So if we have point A, hopefully people will understand, even if you don't agree with it and you're a flat earther, that at the point A here, vertical down is towards the center of the Earth. Vertical up is obviously the opposite to that, and horizontal.
What happens if you're not a flat earther and you disagree with it?
No, all globers agree with what I've just described here.
Okay.
Oh my God, it's backing up and saving it, bastard.
And when you say globers, who do you mean by that?
95% of the population.
And what do you what do you mean by the term glober? What exactly?
Well, someone who accepts the Earth as a sphere.
Accepts.
Anybody who understands that anybody who understands or accepts that the Earth is a sphere would agree with what I'm just showing you.
Okay.
So
is there any particular ritual or something you have to go through, or you just have to?
No, just to be educated. That's all. So go to school. We go to school after about 6 or something. Right. So here we have a point A, and there you can see that down is towards the center of the Earth. The opposite of that is up, and the horizontal at that particular point A is this 90 degrees to that, because obviously vertical and horizontal are perpendicular to one another. But if I were to go to point B, unfortunately my stupid thing is backing.
But not all those horizontals and verticals are perpendicular to each other, are they?
Yes, they are. Yes, all the local horizontals and perpendicular. So this.
Yeah, no, I didn't say local. I said all of those horizontals and verticals are not perpendicular, are they, Rumpus?
They are perpendicular. The local horizontal is perpendicular to the local vertical. But indeed, all these on the surface of the Earth, everybody
how
at a
large
different
is
point
the plane?
On the surface of the Earth has a different horizontal.
How large is the horizontal plane, Rumpus?
Horizontal plane is infinite.
Oh, right. Okay. So all of the
So these
perpendiculars
horizontals
to
that we
that
get-
horizontal plane would be vertical, right? Because they are always perpendicular, aren't they?
The vertical and the horizontal at a point are perpendicular. At
Yeah, but
another
if
point,
the horizontal
another-
plane is infinite,
Hold on,
then
let me
all
finish
of
my
the
sentence.
perpendiculars
Yeah, okay,
to
I'll make.
that plane
Here we go. I'll make an infinite.
must
Hold on,
be
here we go. I'll make an
vertical.
infinite for you.
Okay.
There we go. There's this horizontal plane
Yeah.
for point B.
Yep.
That's different to the horizontal plane at point A. So
Okay,
here's
so
A.
so that vertical and that horizontal are not perpendicular, are they?
No, they're not. That's because
Okay,
everybody in a different position has a different horizontal and different vertical.
But you've just
But
made
at
a
each
mathematical statement that horizontal and vertical are perpendicular, while showing
At a
they
point
are
on the
not
surface of the Earth.
perpendicular.
At
Well, that's
one
not how.
point,
That's not how
they
you make a
are. This is
mathematical statement, Rumpus.
It is.
It's not. That is not how you make a mathematical statement.
At any point
Rumpus.
on the surface of the Earth, at point A or point B, horizontal and vertical are perpendicular to one another.
Yeah.
But the different points have different horizontals.
Doesn't come with a but, a mathematical statement, Rumpus.
It's not. Well, it's entirely valid, I'm afraid. There are horizontals are dependent. They're tangents. Do you understand what a tangent is? The horizontal is a tangent to the surface of the circumference of the circle. Therefore, it changes in angle. Why do you have such a problem understanding this? So every
That's why I asked you
point
how
on the
long, how
edge of the
large
surface-
is the horizontal plane?
I've drawn it in. Jesus Christ! How many times do I have to do it?
Okay,
you
so
moron?
then
I've drawn in this black line.
you know that
I've drawn
all
in this black line,
perpendiculars
which is the
to
horizontal,
the plane.
The horizontal for point B extends infinitely. The horizontal for point A also extends horizontally infinitely. And that's where they cross. So we've got two horizontals on the surface of the Earth. We have a horizontal. Every position on the surface of the Earth has a different horizontal. Every position on the surface of the Earth has a different horizontal and a different vertical. And that's why
and if
the ordolites and things you can demonstrate the vertical's not parallel.
If two straight
And
lines,
you can see here these verticals are not parallel.
if two straight lines be at right angles to the same plane, they shall be parallel to one another.
So what? What's that
Well,
got to do with what I'm showing on screen?
If that plane is a horizontal plane, and those right angles, perpendiculars to that plane, are parallel to each
Right,
other,
so the
would they
verticals.
not be vertical?
No, hold on. What's vertical? Hold on. What are you talking about? This vertical here. So in other words, if I go and grab this thing here, this arrow here. Oh, let's go copy that again. Copy. Control Shift V. Right. So these things, these arrows, are all perpendicular to this line here, and they're all vertical only with respect to the point B. Only with respect to point B. Point A has a different set of horizontal, has a different horizontal, and has a different vertical. Horizontal is dependent on your location. There's nothing incorrect mathematical about that. Horizontal is a function of your position. That's a mathematical statement without qualification. Horizontal, the angle of horizontal in absolute space, is dependent on your position. A and B have different horizontals. They have different verticals.
Right, where did you learn this, Rumpus?
Everybody who's got a basic understanding of geometry understands this. 95% of the population understands this.
This isn't a geometry problem. Like you've just explained that all perpendiculars to the same plane will be parallel. That's a geometrical statement of fact. So the fundamental understanding we seem to have here, misunderstanding, is within the vertical and horizontal relationship. Or the understanding of what vertical and horizontal are. Now, we can only really describe them geometrically, Rumpus.
They're described, as I've said again, towards the centre of the Earth from a point on the surface is vertical. And perpendicular to that, which is also a tangent, is horizontal. Why you don't understand
perpendicular
that is just amazing.
Is straight lines,
Most flat earthers understand.
Do you want me to get you the definition of perpendicular?
I'm showing straight lines on here. I'm showing straight lines on here.
But
what don't you understand about the fact
what
that
you're doing, Rumpus? What you're doing is you're missing the fundamental
reality,
geometry statements.
You're just too stupid. No, either I can't work out whether you're social. I mean, this is just
perpendicular
scale, or whether you're deceitful.
Perpendicular and straight lines.
Can you see my horizontals? Can you see my horizontal and vertical perpendicular here? So here we have
I know
what
that means, Rumpus. That's what we're saying.
So we've got a B. We have a vertical and we have a horizontal that are perpendicular to one another. At point A, we have a different pair. You
travel along the horizontal, Rumpus.
No, we're travelling along the surface of this sphere, which is curved.
So what is the horizontal used for, Rumpus?
Hold on. Do you understand that down is on the globe model, even if you don't accept it, that it's going to the centre of the Earth? Do you understand that's what we define by down?
I know what down is. It's the bottom end of the vertical.
No. I'm asking you
the opposite end of the vertical, the bit you hold, perpendicular.
No. I'm not asking about that.
The bit where the plumb bob points.
I'm not asking
down.
about that. I'm not asking about that. Do you understand? Okay, but do you understand on our model the plumb bob points to the centre of the Earth?
What's your model?
Yes, the globe model.
Show me your model, please, Rumpus.
I would do it. I'm showing you here. So, do you understand?
I just deal in reality, Rumpus. I don't know models. I only know reality.
This is reality. This is reality. This is showing you reality. And do you understand that in the globe model, which is reality, that plumb bobs point to the centre of the Earth? In other words, this arrow here is pointing towards the centre of the Earth. So at point A, do you understand, even if you don't accept it, that down, in reality, on the globe model, let's just stick to the globe model to upset you, on the globe model, that down is towards the centre of the Earth, to this point here. Do you understand? Because you don't seem to understand, because you talk about drop.
The only reference I have.
You don't understand. You don't understand what the globe model. I don't know whether you. I don't know whether you could be.
I might just be autistic, Rumpus. I might only be able to deal with reality.
Well, that could be the case. That could be the case.
Can I just give you a second to relate this to reality, right? If I'm holding a plumb bob, right, down is where the plumb bob points, right, and up would be the opposite direction to that, right?
Correct.
Okay.
Away from the centre of the Earth on a radial, yeah.
Because that's how we measure the height differences along that vertical frame.
On the globe model, on the globe model, the plumb bob points to the centre. Do you understand that's the position we have? Because you've argued loads of straw
I know how a plumb bob works, Rumpus. That's brilliant.
No, you don't. Because you're not answering my question again. You're deflecting. Notice it's everybody. He's not answering the question. Notice that's what he's doing. And I suspect he's going to carry on doing it. But let's see how we get on. Do you understand on the globe model?
Can we get to your test, Rumpus?
See, notice. You see, here we go. See how he's deflecting,
Who are you
guys.
talking
This is the
to,
behaviour
Rumpus?
that annoys them. See, you little wanker. Answer the goddamn question, you little wanker.
Rumpus,
do you understand on the globe model that a plumb bob? You see, you notice how deflecting. He's trying to avoid answering this question as much as he can. Do you understand on the globe model that a plumb bob points to the centre of the Earth?
I only know how it works in reality.
I'm asking if you understand the R position. That's all I'm asking. I'm not asking you to accept that that's what happens.
I understand that you are pretty anal about a question.
Do you understand that's our position? No, here we go. Here we go. You see, here again. You see, he's deflecting, guys.
Are you turning round to everybody there, Rumpus?
See how he will not answer this question. Now, this makes me think. This makes me think that at some level he does understand this is a problem for him. But I can't quite work out whether he's so stupid or he's trying to deceive you. But we'll try again. Do you understand on the globe model that a plumb bob points to the centre of the Earth? Do you understand that on the globe model?
I only know how they work in reality, Rumpus.
I'm asking you if you understand what our model is. And I'm asking you, do you understand that when we say
everybody seems
to
have a different model?
Do you understand what we mean by that?
Do you want to explain to me?
Do you understand what we mean by that?
Do you want to explain to me what your particular model is?
I'm explaining to you
everybody has a different model that they keep talking about. I'm just talking about reality.
To understand that in our model that a plumb bob points to the centre of the Earth. Do you accept that that's what we propose?
When you say we, can I just get
the Globers? Stop deflecting, Bev.
That you're speaking for that 95% of people, was it? That
Correct.
You put yourself in?
Correct.
Okay. And you
Correct.
separated me. You
deflecting
separated
again,
me
Bev.
from
You're
that
deflecting
group.
Again. Stop deflecting.
Because-
Stop deflecting. Answer the question.
Because I just want to
Answer the
talk
question,
about
you
reality.
wanker. You see, here you go. See this, guys? He will not answer this question because I think at some level he realizes this is a problem for him. But he's trying to sort of avoid this in his head. I don't quite understand whether he's too stupid or he's deliberately trying to deceive you. But I think even most of the people in this panel, I think Brian here, I think he understands what we
Brian's
what we
not
believe
here.
to be vertical.
He disappeared when you came.
I think there's
Strange.
a chance that most of the people in this panel and anybody who watches this will recognise, even if they're a flat earther, that the globers say that vertical, the plumb bob going down, the vertical,
95% versus the 5%, is it?
And if you say something different,
how many of those people live in reality, Rumpus?
Which is what you do, you are not accepting our position, you're making a straw man. Our position is that plumb bobs point to the centre of the earth. And do you accept that's our position?
Well, like I said, I told you my position.
No, I'm not interested in what
you
No,
accept
I'm asking if you understand our position.
I only know how plumb bobs work in reality.
Stop deflecting, you wanker. Stop deflecting, you utter wanker. I'm asking if you understand our position.
Well,
our position.
Like I don't understand who
our
our is, who you're speaking for.
Do you understand that's our position?
I don't know who this group of people you're talking for is.
Do you understand that's the global position?
But can you talk about just yourself, right? Because this
do
is about
you
your
understand
test that
that's
you're
the global
doing.
Position? Do you understand that's the global position? Stop deflecting, you wanker.
Rumpus, I
hope
all
the
these globers that you speak for aren't as nasty
all the
as you
globers
are,
will agree with me. All the globers will agree with me.
All
do
of
you
them.
understand that's our position? All of them. Do you understand that's our position?
Okay. Should we title
do
this
you
one?
Understand that's our position.
A glober speaks.
Do you understand
for
that's our position?
95% of the population.
Do you understand that's our position?
Well, I don't know. Do I have to be able to understand your position for you to carry on and tell us about
well,
your
you have
test?
to understand what someone else is saying, even if it's wrong. I understand what you're saying, what you said, what you believe. When you say you believe something, I say, okay, Bev believes this.
Mm-hmm.
Bev believes that level's horizontal. And I understand that. So I've understood what you said. Now I'm asking if you've understood what the glober position is. Do you understand that globers believe that a plumb bob pointing downwards points to the centre of the earth? Do you understand that?
At 45 degrees. I'm struggling because I don't believe that people believe that plumb bobs can alter angle as you move. I don't believe people actually believe that, Rumpus.
Yeah, right, but do you understand that's our position, though? Do you understand that's what we
That's
believe?
your position. I probably understand that.
Yes! I'm asking if you understand our position. I'm not saying
I don't know.
Saying it's right.
I don't know about all of the other people you're speaking for.
I'm asking you if you understand our position. I'm asking if you understand our position.
Rumpus.
I'm not asking you to agree with it.
Just speak
I'm
for you.
If you understand
speak for you.
Do you understand our position?
Just speak for yourself, Rumpus.
Point to the center
Can I have a list that is signed that people have agreed that you can speak for them?
No, you stop deflecting, you wanker.
Well, just speak for yourself then, Rumpus, please.
Stop deflecting, you utter wanker. Do you understand that the globe position has plumb bobs pointing down towards the centre of the earth?
I expressed to you quite
I'm
easily
not asking you to
before
accept it.
what
at that point,
I know
if you
as
understand
down
that's our position.
in reality, Rumpus.
I'm not asking you about that. I'm asking if you understand what globers believe.
Well, you're speaking for an entire group of people, Rumpus, and I'm
yes,
not so sure you are priestly enough to be able to do that.
We all agree on this, and all the books, all the surveying
books,
agree. Any book on geodetics
95% of the population you've just said.
In all of the books, all of them from authorities believe this, state this, and because you've never read a surveying book, you don't.
What about the
this.
dictionaries?
So here we go.
That don't mention relative to a
I'm
position.
asking you, stop deflecting. Do you understand the glober's position is that plumb bobs point to the centre of the earth?
Is there a specific glober's position on that in the dictionary for plumb bob?
The glober's position is that plumb bobs point to the centre of the earth. Do you understand that's what they believe?
Is that where... Can you find us a definition? Because you did say that you have a definition of it. You said you had one for horizontal as well.
let's not deflect. I'll go and get that in a second. Once you will say you understand that that's our position.
I'm like I say, Rumpus, I'm not going to accept that you can speak for 95% of the population. You're a lying
Every single
shit.
glober you will encounter, every single glober that you will encounter will tell you that vertical down a plumb bob will point to the center of the Earth. Try asking them. Go and find any glober and ask them that question. Do they believe plumb bobs point downwards towards the center of the Earth? And you will get a yes from every single one of them who's giving you a non-silly answer to try and annoy you.
Okay.
Every honest answer you will gain will tell you they will say yes. And the fact that you don't
can we carry on with your
this,
test now, then, please?
Well, no, because you. I'm not going to let you get away with
what
this
you're
until you
proving?
Understand.
Isn't this what you're proving?
Understand that the globe
Rumpus?
position. No,
Isn't
I'm
this
not,
what you're
not
going
let you
to
deflect from
prove?
this. I'm not going to let you deflect from this until you understand what you're arguing against. Was no point in proceeding. The globe position is that down is towards the center of the Earth.
See,
and therefore that changes in angle dependent on where you are.
Can I give you a logical problem that you have when you take that circular
I shouldn't
model?
really let you do that. Okay, I tell you what, because I'm a generous character, and even though you haven't answered my question,
it's nice
and
of
I've
you
asked
to
you about
interrupt
20
me to
times,
tell me that you're
I'm going to let you ask me a
do
question
it.
like this,
Yeah.
even though you're deflecting, even though you're
No,
being
I
a
wasn't-
wank about this.
I wasn't asking you a question.
I'm going to be generous. I know, and I'm going to be generous about this,
I was
despite the fact
just-
that you're deliberately doing it to deflect from this question, which I'll come back to immediately after the question you've asked me. So don't think you're getting away with it. But I'm going to be generous because that's the kind of guy I am, and I'm going to let you ask me a question and have a tangential deflection from the subject the question I'm asking. So go ahead.
Right. The
Good morning,
problem.
Bev.
Wait a minute. The problem you have is that if you take the spherical model and a vertical being the extension of a radius past the circumference, perpendicular to that is a straight line. But you only have a perpendicular at a point. You have a zero horizontal plane. Oh, wait a minute. Let me finish. You have a zero horizontal plane. It cannot exist as a place, only as a point. In turn, that means you have a horizontal circle. Bit of a logical problem. So that's why I'd say not everybody agrees with what you say. Because you don't really understand the geometric problems that you are making for everybody.
Oh, I do. You just have no understanding of geometry. Do you understand what a tangent is?
I know what a tangent is.
Do you understand? Yes. Right, good. So you will understand that the tangent only reflects the gradient. So if I zoom in on here. So if I
can we get to your test?
Here we go. Hold on. No, we're dealing with your question now. So at this point here, if we zoom in, this black line is a tangent. So there's the curve. This blue line is the curve.
That's more than a point, that, Rumpus. It looked like it's touching at more than a point.
Yeah. Well,
so that's not a tangent, is it?
Imagine I could zoom in. Imagine they were getting thinner.
Just imagine it is actually a tangent, though it's not a tangent.
Be quiet.
Okay, fair enough.
It is a tangent.
It's touching all of that line's touching. It's not just touching at 1 point, 1 point only.
It's an infinitely thin line.
It's touching quite a few points.
That is
not
so
a
you
tangent.
don't. From your question you've just asked me means you don't understand what a tangent is. So there we have a tangent, that black line, and it exactly matches the gradient of the blue curved line at this point, but only at this point.
So that straight line and that curved line are both the same, right?
Yes.
At that point that isn't a point. The straight line and the curved line are the same, is what you're saying.
Yes. At that point. That's what a tangent is,
ridiculous,
you utter moron.
You don't seem to understand.
You don't understand what a tangent. You don't understand what a tangent is, do you?
You don't understand
at the point,
the fundamentals of geometry.
At a tangent, if I made that infinitely thin, at that point, the gradient of the curve and the tangent would be identical. And what we've done here is what you said earlier, but once you've got a line, you can extend that line. There's no problem. There's absolutely no conceptual problem in saying this is the line that represents, which is a tangent, to that point. So I've just extended it. So there's no issue about extending it, as you asked in your question, at all. All I've done is demonstrate here's a tangent. And the fact you don't understand that, or you're questioning this and you think this is a problem, means you don't understand what a tangent is. Anyway, so now I've answered your question. Let's go back Do you understand that in the globe model, that the globers believe that down a plumb bob points to the center of the Earth? Even if you don't agree with that's what plumb bobs do, that is our position. Do you understand?
I know you've just
position?
glossed over that in your head, right? But I think everybody's of the understanding that you don't know what the basics of geometry or understand what a point is.
Well, it's obvious to anybody who does. Anybody who saw what I just did will agree with me who knows anything about geometry, so you're just wrong.
A point can't be a line, and a line can't be both straight and curved at the same point, because that's utter
That's what a tangent
gibberish.
line is, you moron. A tangent line meets at a point, but it has length. It is a line. You don't understand what a tangent is, do you moron? So anyway, we've dealt with that. So do you understand that the globe model says that plumb bobs point to the center of the Earth? Do you understand that that is our position, even if you believe it doesn't? That plumb bobs don't do that. Do you understand that is our position?
I understand that you're speaking for a lot of people at the minute. I do.
Okay,
I get that.
the people that I'm speaking for. Okay, for the people I'm speaking for, do you accept that's our position?
I accept that you're speaking for a lot of people at the minute.
Okay, and do you accept what we're saying, which is that we believe...
I don't accept that you are speaking for them, and I'm not going to agree to something that you're speaking for a group of people that haven't confirmed that you've got the ability to speak for them.
Well, if you look up any...
You've given yourself that power, Rumpus. You've sort of making yourself a priest of the globe at the minute, and you are speaking for your globe subjects at the minute, and that you are all speaking from the same hymn book. You're all
so if I go and get a surveying book
from the same.
So if I go and get a surveying book, then that shows the same thing, will you accept that?
No, we're just doing basic geometry, right, Rumpus? And
now, hold on, now you're dodging again. You see, you don't like that now, do you? So if I go and get a reference from a surveying book, will you accept that that is the position
we
that
want to get
hold?
Your test on the go.
There, you see,
so
you're deflecting again.
Listen,
you're being a wanker. See, everybody? You see there? You see, this is what makes me think at some level he's not comfortable with his position.
Who are you talking
see, immediately
to,
I suggested that I can speak for the global community by referencing a surveying
you've got
textbook.
like a big group of people there.
His response was, let's go and talk about something else. So this is why everybody believes that Bev is a complete wanker, because he doesn't
Everybody,
engage
again, you're speaking for a lot of people again.
Just get on with talking about the test, please.
Is the consensus. He immediately tried to deflect onto another subject. And this is what makes him a debating wanker. An utter wanker.
Are you speaking for 95% of the population again, Rumpus?
Yeah, and I'm speaking on behalf of surveying textbooks as well. And I noticed immediately I brought that up.
You're not speaking on behalf of surveyors, are you?
Because you don't like surveying textbooks, do you?
You're not speaking. Please don't speak for surveyors, Rumpus.
I'm speaking for surveyors.
Please
I'm speaking
don't.
for surveyors because the surveying textbooks. I'm speaking on behalf of the surveying textbooks, and surveyors follow the surveying.
Well, I'm going to speak on behalf of surveyors and say Rumpus doesn't actually mean this. He's not actually.
So you're contradicting the surveying textbooks, then, aren't you? You're contradicting surveying textbooks, all of them. You are now contradicting all of the surveying textbooks.
I know that surveyors use horizontal planes as a daily part of everything they
we know
do.
That. We do that. There's approximations. Yes, we know that, but you're still contradicting surveying textbooks. Let's go and get surveying textbooks, shall we? Because you seem to. We want to demonstrate you are contradicting them. Let's do that.
Oh, mate, I've been waiting half hour for this test. What's this test, and can anyone turn up and join in?
Well, the trouble is, I'm having a problem. I don't know what you're like, but I'm having a problem with Bev, who is deliberately deflecting from some simple questions.
We're trying to get to the test. He asked about the test.
No, you're not. I know you are, but you're in the process of you're doing is to deflect from simple questions.
No, it sounds like you're deflecting about talking about your test, Rumpus.
No, here we go. You see deflecting again, aren't you?
You should want to talk about your test, Rumpus.
I do, but
I'll talk to you about our test after you've explained yours, right? Just do the test, Rumpus.
Let me just get this surveying. Let me just go. Hold on, I want to go and get this surveying text.
Oh, mate. It's got a half hour now.
Yes, well, unfortunately, Bev, because he doesn't engage honestly, and I have to pin him down and ask him the same question 20 times before he'll answer, or he'll not answer at all. This is why it's unproductive to talk to Bev. He's not interested in having.
Don't talk to me then. Talk to everybody else about your test, please. Please.
Yes, okay. I will. Yes, I might do that actually. But first of all, I do want to show this this textbook to show that I'm speaking on behalf of surveyors.
Okay,
So
now
I'm just
please stop talking to me, Rumpus, because you've had enough of it. Talk to everybody else in the room, please.
Okay, I will talk to them now. First of all, I'm going to talk to them about the contents of let me just give it in a second. Give me a moment.
Oh boy. Morning, Bev.
Here we go. Right.
Morning.
Right, guys.
Just doing a brew.
Right. Okay, let me just change my screen here.
Hey guys,
Oops.
night. I was just saying good morning.
Right, I should be sharing. Yes, here we go. Right, so here is a surveying textbook, 6th edition, a standard text for surveyors that learn surveying. And let's go and have a look at what they say about this, what constitutes down, which Bev was claiming I did not represent the people or the authorities about it. So let's go and do that, shall we? So we can show that, in fact, I am entirely speaking for the world, and
the
Bev
book.
is not.
For the
Bev
book
is
that you're
contradicting.
referencing. That's what you're speaking for, isn't it?
Say again, I didn't hear that. Right, here we go.
You're
so here
you're
we
speaking
go.
on behalf of the book. That's what
Yeah.
you're speaking on behalf of.
Yeah.
Not the people.
Yeah.
The
Well, surveyors. This is what people who do surveying. This is what they learn from. So here we go. Oh, what the hell's going on here? Right. So here we have a diagram. Let me just make it a bit bigger. Scroll here. Right. So this is a standard surveying. What the bloody hell? Standard surveying book. This is what people use to learn about surveying and become surveyors, become chartered
Rumpus,
surveyors.
we have conversations with actual surveyors here. Most of the people in here have already done that.
You haven't learned anything. You claimed that I was not speaking on them, and you therefore didn't understand what they were saying, because they would be saying exactly the same thing.
We've talked to surveyors.
Well, yeah, you haven't understood them. You haven't understood. You may have.
Okay,
you
so
haven't understood
you're
them,
now
or you haven't
speaking
explained
for
it.
the
There's been a
surveyors
problem.
that we've already talked to.
Correct.
So I was just pointing out that I hope you don't want to do that, because they've already talked to us. They can talk for themselves.
No, in which case you've misunderstood them, or you've spoken to someone who's not a proper surveyor.
One more clarifier, Rumpus. We are not saying this about surveyors that Rumpus says we are. Okay. Carry on.
Okay,
talk about what you want to talk about. Don't talk about us. Please.
Okay, I'm not going to talk about you. So here we have a book, a standard textbook. It's many hundreds of pages long. It's the 6th edition. It's written by I think some bigwig in the surveying, chartered surveying authorities. British book, and accepted text. This is what people will be reading if they wish to become surveyors. They have to understand things like this diagram here. This is the standard text, standard. This is what Jessica Kozlowski and anybody else who interact with chartered surveyors will have to understand. And here we have the direction of gravity. And as you can see, it's not parallel. And also it describes what level means. Level is curved. And there's horizontal. There at the top is horizontal line through C. So that's exactly what I was describing that Bev said was a problem for some reason. There's a tangent at C. And that's the horizontal line. That's what an auto level will show you. But level. And here we've got two levels. We've got level A and level B. These are two levels. They are curved. They are not horizontal. That's horizontal. And notice how vertical the direction of gravity is towards the center of the Earth here, and they're not parallel. And that means because, as you can see here with this little right angle, horizontal for that thing is going to be perpendicular to that point, and therefore the horizontal at A and A dash is different. The vertical at A and A dash is different. Vertical, the plumb bob will point down to the center of the Earth, as I said, and therefore upwards is along a radial going away from the center of the Earth. This is the standard position of all surveying authorities, all globers. This is what we all understand. Bev doesn't understand this. Bev doesn't have a surveying book, because if he did, he would also be able to look at such a thing and see a diagram and see that he's being contradicted by the very text that he supposedly believes in, because he believes in surveyors presumably doing a proper job. And so there we have it. We have the textbook definition of down, horizontal, and level, and it completely contradicts what Bev said. There we go. So I'm speaking for them. I'm speaking on behalf of Glovers. I'm speaking on behalf of all the surveying institutions around the world. There we go.
Amazing.
Now can we do your test and show us how you're going to measure that difference, please?
Right. Well, in fact, this diagram is absolutely relevant. Actually, this diagram is absolutely relevant to what I'm doing.
Have you not done one for your test? So we can see what you're doing on your test.
When you want to see a diagram that I've drawn this morning.
Yeah, I want to see what you're doing for your test, the procedure, the method that you are using when you do your test.
Yes, I'll effectively be doing what this diagram shows. I tell you what, I'll actually grab this diagram.
You're doing it at Bedford.
So,
there's no big hills there like that in Bedford. You have been there, right?
Yeah.
Right, so there's no big hill, so you can't use that diagram.
I can use this diagram. So I'm going to use this diagram.
Wow. Like I say, I'll ask you again. Do you not have anything for your test, Rumpus?
I do, but I'm going to use this diagram. I'm going to use this diagram.
Why can we not see something to do with your test, please?
Because this is what I'm basing my test on, this diagram. What did
I don't think you're doing a test, are you, Rumpus? Have you got anything?
Yeah, I am. Oh, I am.
Have you actually been to Bedford, Rumpus?
I've been there about 6 times with about 7 people and installed some things.
What pictures? Have you got any pictures of that? Then we can see what equipment you have.
I have lots of pictures and videos, but the fact that you've just questioned whether I've been there, I'm not going to bother to show you those.
That's convenient. Have you got any pictures of the actual method that you're going to be using?
I do.
Okay, can we see those, please?
Go through it with No, I'm going to do it with this diagram from an engineering, because it's effectively the same thing. So here we have. I'm going to use this diagram, although mine I actually prefer mine, but I'm going to use this diagram from an engineering book because then you can see that I'm using it.
You haven't got a diagram of your own, have you, Rumpus?
Oh, I have.
You've never actually been to Bedford, have you, Rumpus?
I want to use this because I want to show you that I'm completely in agreement with.
You want to show us that you've been there and you've actually doing a test by not showing us a fucking single thing.
Correct.
Brilliant. That sounds like you. Are you speaking on behalf of the 95% of the population again?
Yes.
Right.
So here we have what we're doing, and I effectively have the point C here is effectively the observation point on Welney Bridge.
Well, Rumpus, sorry mate, will you show us the pictures and not Bev?
No.
Oh,
I'm afraid
just saw that was one of the little silly games you might play. Like, where's your test? Where are the drawings and explanations about what your test is, please?
I will be putting up a video on YouTube very shortly about doing just that. But I thought I'd go through with you using. I will be putting up some videos very shortly.
So you're making this test up literally right now while we speak? Is that what you're doing?
No, I'm going to show you. I think it's useful for me to use the engineering, the surveying drawing diagram, so that you understand that I'm agreeing.
The engineering drawing diagram.
Yes, I said engineering surveying. This book is called Engineering Surveying. So I'm going to use this diagram because it's from the book. And so therefore,
is that diagram in the first issue?
Therefore, you can't claim that I'm somehow in contradiction to it.
What was the engineering project that this thing depicts?
Doesn't matter. So this is
it's like a pretty big hill. It takes up about an eighth of the circle that it's on top of. I mean, you sure that's right?
This is a text. This is an engineering surveying.
Looks like a big engineering project, that, Rumpus.
Bev has never read an engineering surveying book, unfortunately. So anyway, here's the principle.
I've looked at that, and that looks fucking ridiculous, Rumpus.
So here we have, on my situation, point C. So I'm going to draw on this. This is where effectively that we have. I'll go and get my This is the observation point at
Sounds
Welney.
like a deflection.
There. So it's point C.
You're doing this on the fly, Rumpus. Just show us what you've got prepared for your test.
No.
Just give us a quick glimpse of it. Just give us one picture, then we can know what it is we're looking at for your particular method, Rumpus. Like, I've got this camera here, I've got this auto level here, I've got this theodolite here, I've got a stick over there, I've got another stick over there, I'm going to be looking at the sticks from here to there. Have you not even done that?
Yes, I have. But I'm going to use
this. Can we see that drawing, please?
No, you can't.
Oh.
You will be able to see it in a few days, possibly a week's time. But at the moment, I'm going to use this diagram from an engineering textbook because then you will understand that I'm in agreement with an engineering textbook.
You're a farce, Rumpus.
If I present you with a diagram, you're going to say, well, what you did earlier.
I'm going to say you're full of shit, Rumpus, like I always have. It's obvious you are full of shit.
I've exposed you as a wanker. I've exposed your deflections, and you don't like the fact that I'm using an engineering surveying diagram. You don't like that fact because it exposes the fact you're contradicting surveying textbooks. I'm going to continue with this and show what I'm doing. So here we have an observer at sea with an auto level, and they're generating this horizontal line with an auto level.
At sea with an auto level, did you just say?
I did just say that.
Up in the air.
No, at sea.
Therefore, the drop.
Oh,
at the same height as the mountain.
Yeah.
You're going to have like breathing apparatus and that.
So
big ladder.
Then we are going to measure this thing here, that drop there at several points along here.
Do you have a name for this specific surveying procedure where people go up big ladders?
My test is called RECT, the Rumpus Earth Curvature Test. You'll be hearing a lot more about that very soon.
Right, and that involves erecting big things that you can stand on and put an auto level at height.
The auto level is on the bridge. I didn't write that to here. This is the observer at Wellneat Bridge, if you like.
Wellneat Bridge? So that's in the middle, Rumpus. Wellneat Bridge is in the middle, isn't it? Wellneat Bridge is in the middle, right, Rumpus?
Middle of what?
In the middle of the Bedford Canal.
Yes, so.
Right, so that's in the middle at the 3 mile mark is Wellneat Bridge. Where are you putting that?
3 mile mark. I'll say it again. I'm putting an auto level on Wellneat Bridge. I mean, how many more times do I have to say this?
And that's the midpoint. I'm just letting everybody know that Wellneat Bridge is the midpoint.
Doesn't matter. We're only measuring from one. We're going.
I'm just trying to let everybody know, right? Yeah.
It's irrelevant. It's not a relevant point because with that is the.
It is a relevant point because if you're doing a 6 mile test and you're telling everybody you are putting the observer in the middle, then you're only actually sighting 3 miles, Rumpus.
I didn't say I'm going in the middle. You said that. I never ever said that.
You said Wellneat Bridge.
You said. Yes, I did, but I'm
right
not
now. Is Wellneat Bridge in the middle?
It's not the middle of my sighting. It's one end of my sighting. You utter wanker.
Wellneat Bridge is in the middle of the Bedford Canal.
Who cares? It could go on for 27 miles in the other direction. I'm only going from the bridge to in one direction. You twat.
Okay, so you're only doing 3 miles then. Okay,
moronic twat.
Brilliant. We've just halved the test distance.
I've got a question.
You stupid moronic twat. Jesus Christ. So I'll say it again.
But Rumpus, can I ask you? Did you what's at sea point? What was that again? Because it looks like it's in the air.
Yeah, I've put it at the raised position. So A is I'm saying is the water level. So I'm going to say here's the base of the canal. Here's the water level of the canal. Water level.
The base of the canal.
The water level of the canal, as I'm writing here, moron.
Is that the base or is that
the water level of the canal?
Right.
And I'm at C.
What is A?
Try again. A is the water level of the canal, as I've written there, and C is the observer with the auto level height at Wellneat Bridge. How many times do I have to repeat this? you utter moron.
Wow, there's no need
Just
for
try
that.
and
me a
Observer
moron
at
now.
water level.
I'm just literally
So
asking you to explain the letters because
And I
my
did,
eyesight
and I
isn't very
kept-
good.
and
And
I
now you're
kept
calling
on
me a
telling
moron.
you are a moron. And I explained to you several times that A was
Rumpus.
the water level of the canal.
Oh, thanks.
So
Thank you.
good, right, good, excellent.
Oh,
Well,
but I'll
told you
keep
that
quiet
before.
now. You
Must be
carry on,
important.
mate.
Yeah, oh, good. So here we have the water level of the canal is A. So let me perhaps help you out by make it blue, so you sort of get a vague grip of what's going on. So if I put that in there, let's make that blue, and let's make that go back, so you can think of it like this if you like. Let me just make that a little bit.
Hey, at least Rumpus is not cursing when he's talking to himself. That's nice.
Right. So there we go. So that I haven't quite got that right. Let me just do that a little bit better. So my diagram is much better, but I'm doing it on this diagram just to make sure you understand how I'm completely agreeing with the engineering survey diagram. So here we go. So there we have the water level of the canal. That's A on there, but we've overwritten that. Let's put that back in again. A. Right, so there's A, the water level of the canal, and there's C, we're on top of Welney Bridge, and we're using an auto level to generate this horizontal line that goes through C, the height of the observer on the bridge, and the water bends away like this. And what we're going to do by these poles we're raising is we're going to measure the size of these things here. We'll call that D, E, and F. Whoops. And so by raising the poles up and down at the points along this, so there's a distance here of about 8 kilometers, or 10 kilometers actually, along this point here. So I'll draw that.
10 kilometers. Oh my fuck.
So here we go. So that distance there is 10 kilometers from one end to the other. And we are going to be measuring the drop that occurs along this distance by raising up poles to intersect with the horizontal. And so just by doing that, we can establish the existence of drop, and we'll be showing you there's about a 20-foot drop, and we'll be able to show you, actually, we'll be doing this live streaming it, and you'll actually see people raising these poles, and you'll see the same thing being shot from the bridge simultaneously, and then we'll see through the auto level the target meeting the horizontal, and then you'll be able to see that we've had to raise the post up 20 odd feet for the target to match the auto level position, and show you actually it's 30 feet because the bridge is, as you can see in this diagram even, is above the water level, so we have to allow for the fact we're on a bank and we're starting off below. Nonetheless, we'll be able to show you there is a drop of about 20 feet odd.
So you're doing your observations from the bridge.
Correct.
Okay, so it's not like Robotham then, right? Because you're using sticks on bridges.
Yes, it's not Robotham measured the bulge. I'm measuring drop.
Okay, so
I'm doing what Jordan did.
What are you using the bridges for then? Why at this canal? Like, why are you doing it there?
Because it's a straight. I can see through the auto level and through a camera. I can see all the posts in a line and line them up with the auto level's graticule.
Yeah, you know that bit that
wow,
that Cats sent us to at the side of the beach. That's a longer, straighter bit, and you can see what you're doing.
I didn't. You broke up at the start of that sentence. I didn't hear what you said.
You know the bit that Cats sent us to, the Velvet Trail car park at Southport Beach. Well,
the bit that guy took the picture of Blackpool from.
Well, not on top of the dune. No. The seafront there, on the beach, right where the water comes to. Right, that bit there is a lot straighter and it's a lot more visible. You'd be much better there. You wouldn't need to go on bridges. I mean, I take it you've got a permit, right, to hold your sticks up on the bridges.
It's a public bridleway.
Okay. So, but big sticks at the side of bridges, and your test has come down in size, right? Because initially you were proposing the 6 mile test, weren't you? the full length of the canal.
Well, 10 kilometres is 6 miles.
Okay, but you had your observer at Welney Bridge.
Yes.
Well, that's in the middle.
It's not. There's a 10 kilometre run beyond Welney Bridge in one direction.
No. It goes 3 miles one way and 3 miles the other way. The Welney Bridge is the midpoint.
No, it doesn't do that. You're wrong.
Oh, have you been there?
About 8 times.
Okay. Did you always go to Welney Bridge?
Yes.
Right. So, and which direction did you face? You know, like you see in the live chat there, that's Welney Bridge looking at the sluice gate.
Yes.
Right. Which direction are you facing that way? Is that the direction that your test is going?
That looks a bit different, I must admit. Yes, I think I can.
It will look different because we were there way before you. Like, now, where are your sticks that you're holding up? Where are they going to be?
I'm not prepared to tell you.
Are they're in that direction though, are they? 6 miles?
They might be, but they might not be.
Okay. I'm not going to go there and steal them, Rumpus. Don't worry about it. I'm just on about the test. When you're going to be positioned on Welney Bridge, looking down that canal, right?
I will on Welney Bridge, is what I'm prepared to tell you.
Okay. Looking down the canal, though, and then at some points down that canal, you've got... Yeah, one way or the other. I thought you said that was the end, so you had to look at which is the direction that's 6 miles, obviously.
You're breaking up. I can barely hear you.
That sounds like you're breaking up to me, but let me jump out.
Okay, perhaps I'm...
Welcome, George.
Hello there, Montreal. It's been a while.
Yeah, welcome back, George.
Glad to hear you.
Well, not really.
What do you mean? It's not good to hear you. Of course it is. Last time we heard you, we chatted on Brandon's. You disappeared after that.
Well, there's been a lot going on in my life since then.
Not because of the chat that we had on Brandon's, I hope. I hope you've not got yourself into trouble.
No, I had a devastating house fire. I lost the house a while back.
Which house?
The house I lived in.
I thought you had a few houses, didn't you?
I said the house that I lived in.
Okay. So did you just move to one of your other houses?
No, the other houses are in other states. House in Colorado I'm selling at the moment.
Okay. So which one was it then? Not Rainy Lake?
Yes. The Rainy Lake house where I live. Lived.
Is that where you did all your data and everything?
Yes. Yeah, I lost all my surveying equipment. The Adelites and everything are just a pile of glass and melting slag.
You had insurance, I hope, George?
No.
No. Well, you
They
didn't
kept
use all of your
the insurance
reflection
companies.
stuff.
Insurance companies kept canceling me out because I had 2 fireplaces. And the irony of it all is that fire had nothing to do with the fireplaces.
Of course. Wow.
Yeah, shit happens.
Oh, that's sad to hear. Yeah, sad to hear.
Yeah, you're telling me. I miss my stereo system. Lost everything. Oh well. So what do you want to know?
Well, Rumpus, we were wondering, what's the skinny on Rumpus's test?
Oh, basically what he's doing is what I did several years ago, where you set up a number of targets. He's setting up 2 targets, one at about 3 miles and one out at 5 miles, and you view them through an auto level and adjust their height until they're at the excuse me, my voice is not really good right now. You adjust the height. You have someone viewing the auto level and in communication with you, and you adjust the heights up and down until the targets are centered on the crosshairs of the auto level. And then when you're got that established, you measure the drop distances down from the center of the targets down to the surface of the canal water to see if there's any drop.
Did you say at 5 miles?
Yeah, his last target is at 5 miles, and he has a middle target, I believe, at right around 3 miles.
And he's going to sight with the auto level at each of those distances?
Yes, what you do is you look through the auto level, and you have someone adjust the target heights so that the center of the targets line up with the crosshairs of the auto level. That's basically what I did a few years ago on the frozen ice of Rainy Lake. But he's doing it over unfrozen water, canal water.
He's not doing it over the water, is he?
Yeah. The targets are mounted on the shore bank, the bank of the canal. And then you measure down from the targets to the surface of the canal water.
Have you been there? Have you seen it?
No, I've seen his videos. He's taken quite a few videos from camera and from drones showing me what
drones
he's doing.
As well.
Say what?
Drones as well. He wouldn't show us anything.
Well, no, he's just getting things set up right now. I've been helping him out with some of the engineering issues regarding the problems that he's encountered.
Plenty of problems, eh?
Oh yeah, there's always problems whenever you're doing a real test, he was a little bit optimistic, overly optimistic to begin with, and I think reality's sitting into him that this stuff is not easy to do.
What's the auto level? Do you know that?
What do you mean? What is it? You mean the make?
Yeah.
Oh, gosh. I'm trying to remember it.
Because 5 miles is quite a distance for an auto level, do you not think?
As long as you can see it in the crosshairs and your optics are strong enough, enough magnification.
That's why I was asking what sort of auto level he's got.
Yeah, I'm trying to remember. Well, I do. I've done 6 miles quite easily using my TopCon auto levels.
What sort of magnification were they?
32. Oh. 32x.
Yeah, that's not that good, is it?
Well, his is. I've used both a 24. Actually, I had 3 auto levels: a 24, 28, and 32. And then, of course, my theodolites were 30 times magnification. And in all cases, I could see the 6 mile targets, even with the 24x CTS Burger auto level. That might be what he has as a CTS Burger, but don't quote me on that. I'm not exactly sure, but I think that's what it might be. But it's just that, of course, with more magnification, it's easier to line things up. And
how big are the targets that he's going to be looking at?
Well, the 5 mile target is about the same as size as my 6 mile target, which is about 5 feet high and 3 feet wide.
Wow, and you've got, how high's he got to lift that?
He's got poles set up where a telescoping pole essentially,
with a
and
winch.
He can get it up to 28. He can get it up, I believe, to about 28 feet above the canal or more, depending upon how high up on the bank he mounts it.
5 by 3. He wants to hope it's not fucking windy. In fact, not even breezy.
Oh yeah, that is a problem. He's discovered that to be a problem. Yeah, and so he's devised a scheme to tether it, to guy it down, with 4 cables with stakes in the ground to give it stability in a wind.
Yeah, but you said at the canal bank. I'd imagine that's going to be tough.
Oh, it is. That's what I'm saying. He's finding a lot of engineering issues that he hadn't anticipated, but we're working through it.
Yeah. Well,
that's the same with any of this stuff.
Do you know when he's going to go and do it?
Well, he's been doing. He's gone at least 5 times now. He's getting things set up. The big problem that he has is that they have to do a lot of hiking. They can't drive to all the spots. So in some cases, it's taken them 45 minutes to hike to the spot to where they're setting up the targets. So, and there's been a lot of bramble and a lot of high bushes and stuff to work through. So, it's been more of an effort than, I had first thought.
It's a public footpath on top of that berm, though.
Not exactly where he's going. From what I've seen, the footage, there is some stuff, some places where it's pretty rough.
Oh, well, I'd imagine if he's going, if he's having to go down to the canal bank, I mean, it's just a big ditch, really. So
but it's grown up quite a bit.
Side. Yeah,
but it isn't like a mowed lawn or anything. There's a lot of bramble and bushes,
a lot of reeds
and stuff.
And all sorts of stuff in the side there. I mean, when we went there, they had to clear the side. Especially, is he getting them to do that for him to make sure it's clear, the council, or is he just sort of going along and erecting this stuff? Because I think when we went, Dr. John got him to clear the side of the thing, so we had a good line of sight all the way through it. But I suppose if you're going from the canal, from the bridge, and you're erecting posts at the side of the canal, I don't think you'd need to really bother with the canal, would you? Why Rumpus couldn't talk like that about it? George didn't need to work out what down was or anything. So much different, George.
I'm sorry. My microphone got muted. I didn't know my mouse pointer crept over to the microphone. Maybe you didn't hear a lot of what I said.
I didn't hear anything of what you said just recently, no.
Oh, jeez. Okay, I was saying, in regards to the council or the owners of the canal, I don't know what Rumpus has done in terms of communication there. I'm leaving that part of the logistics up to him, as I've just been helping him with some of his engineering issues, overcoming some of the difficulties and stuff that he found,
There's not much engineering difficulties in that, though, right? You've got to look and see. Has he done any testing to see how far his auto level can actually go?
Yes, he's been there about he's been there about 5 different times here in the last month on weekends. And the part you probably didn't hear is that they found it a lot more difficult in setting things up because they have to do quite a bit of hiking. They can't, where he's setting up some of this stuff, apparently they can't drive there, and there's a lot of overgrowth and bramble and bushes and stuff that makes it difficult hiking.
Yeah, with a 5x3 board or whatever.
Yeah, he's kind of overbuilt it. He builds it for an eternity, and I've tried to advise him on that, but his damn thing is so heavy, and it's quite a heavy sail when you put it up on the posts, and that's creating a lot of difficulties in itself. But that's Rumpus. I mean, he overbuilt it, and for one of a kind test.
Telescopic pole with that 5x3 sheet on the top of it.
Yeah, there's basically the way it's constructed is there's a I don't know what the standard diameters there. I can't remember what you have in the UK, but for us it's like 4-inch diameter sewer pipe or PVC pipe, and put a long 2x4 in there, and there's a rope attached to that with a pulley at the top of the pipe. So you've got like a wood staff inside a pipe, and then you pull it on up, and then he's got a collar on it to which he has a number of lines attached to guide in place, to hold it in place to withstand breezes and winds and to keep it from toppling over.
30 feet. Nearly 10 meters.
Yeah, it goes, I think you can get up to about 28, 30 feet, somewhere in there.
Wow. You could perhaps have a go at doing the 33 feet. Can you? If you could erect one of these, can you get us the plans for it? Because that'd be ideal for us, a telescopic pole of 33 feet. Has he got a winch on it?
Yeah, you can just pulley the water hose up it.
And off you go, right? You wouldn't even need to put a big board up there. You just need your camera, the bottle. That's it, really, isn't it?
This is basically what I did several years ago. Is our PVC pipes that what's standard here in the States is 10-foot long, 4-inch in diameter. A sewer pipe or PVC pipe. You can do Schedule 40 or Schedule 80. I usually use Schedule 40, which is a heavier pipe.
Yeah, they're that wibbly wobbly though, right?
Well, no, not a 10-foot long pipe.
Yeah, but you've got to do 30. You've got to.
Yes, let me finish. I'm telling you how to build it. Is the standard pipes that we have, like I said, are 10-foot long, 4-inch diameter, and they have flared ends where you can stack these end to end if you want, And usually I did 2 of them to get 20 feet, and then I would buy I guess we can get longer 2x4s here than you can in the UK. Rumpus was saying the longest he could get there was about 20 or 22 foot. I can get up to 28 foot here, but say if you just even took, say one of the sewer pipes and stacked a half on top, so you have a 15-foot sewer pipe, and then put, say, a 20-foot, 22-foot 2x4 inside. And then what you do at the top of your pipe is you make a top that the 2x4 can, 2x4 will fit snug inside a 4-inch pipe. So if you pull it up inside the pipe, from inside the pipe, you can hoist it up as a telescope. The 2x4, you lift it up out of the pipe, and then affix it with a some guy wires to stakes in the ground to hold it in place, and it's pretty easy to manage.
Yeah, come on, George. A 30-foot thing with 5 by 3 foot sail at the top of it.
Yes, but you guy it down. You tether it down.
And
Bab, you tether it down to stakes in the ground.
I understand that, George, but that's still one hell of an operation.
Well, it is.
Yeah.
I did that. I did that out on the ice, and I went up 28 feet that way with a large target, and it withstood winds out on the ice at 35 miles an hour.
You sound like a practical guy, George. You sound like you do stuff like that, and not to be, funny about it. Rumpus isn't that sort of a guy to me.
Oh, he isn't, but he's learning.
Yeah, but that's one hell of an undertaking to do that, what you've just said. Not only to actually erect it and get it all there, but to actually make it as well. I don't think Rumpus is capable of doing that. I'm sorry.
Well, he did.
He must have help.
Well, yeah, he has. This last time he went out, he had like 5 people with him to help him.
5? Wow.
So, yeah, he can't do it by himself. I mean, I did all my stuff by myself, but it was quite a struggle.
Yeah, we did ours by ourselves as well. It's not that hard when you make it easy. Simplify it. This one sounds like a nightmare.
Yeah, well, like I said, it's ended up being not as an easy operation as he had first anticipated.
Do you know if he's tested his auto level to see what he can see 5 miles away with that board?
Yes, they did this. They did this last weekend. Right. They made a first test.
Nice. So there's pictures of that test of what we can see through 5 miles.
Well, I don't know that they took any photographs through the auto level. They were just doing a proof of principle.
All right. So, but it was good, right? He got a thumbs up.
Well, that's what he said. Yeah, that's what he said. Right. Yeah.
Nice.
They do have some concerns, though, about some of the trees on the banks getting in the way at times. When the next thing they need to do is get both targets erected at the same time to see if they can get them all in line without being, obscured by trees.
Right. Oh, I see. So he tested the 5 mile thing. He lifted it, hoisted it up, put his auto. But that's basically the test, isn't it?
You want to have more than just one, though.
Yeah, I know, but he must already know how the test's gonna go. If he's put it up and hoisted it all up on that thing and done his 5 mile thing already, I mean, whether he took the pictures or not, he must already know. Because like you said, he can see it. If he can see it over 5 miles at Bedford, then
I don't know. But Bev, I don't know if they I don't know if they had the time or took the time to sight it so that it was lined up with the crosshairs. All they wanted to do is to see if they could see the target. Whether or not they actually went through the operation to get it all lined up, that I don't know.
Well, yeah, but the auto level would have had to have been set up horizontal, right? And he must have been able to see it over the 5 miles. I mean, that's good.
Yes, yeah. They could see it. They could see it.
Really good.
Yeah, they could see it in the scope of the auto level, but I don't think they had the time by the time they were all set up and stuff to sit and play with it to get the target lined up with the crosshairs of the auto level,
they got the target. They got the target up 30 odd feet up in the air, and you could see something in the air.
Yes, exactly.
Oh well, I'd like to see that. Some pictures of that. That'd be great. Well, I mean, that obviously, if he's got the thing up in the air, tethered down, all the kit must be there, ready. He's ready to go then.
No, the way I understand it is that they have to dismantle the stuff at the end of the day. So he's worried about leaving the stuff up and having people mess with it or, taking it down.
You reckon? Nah, it's not the sort of place around there, is it?
See, that's the difference between him and I. Is I would be in direct communication with the landowners and the canal owner to make sure that to see that I could keep it up, without having someone messing with it.
You wouldn't be able to leave it up. That's for sure.
Yeah.
You'd be struggling for him, letting him know what you're doing, right? That's the danger.
Because it's not. Yeah, it's not like the thing he can go out and check every day. I mean, he lives like 2 hours drive from the place. So there are logistical problems that he has to deal with there that he has to be concerned about.
Yeah, fucking hell, yeah. He's took all of that kit, and there was 5 of them. It'd be like a bus trip.
Yeah.
With all of that kit and everything. I mean, yeah. Well done. I can't wait to see. He said he's putting a video out. There must be loads of footage.
Well, I don't know how much they actually take. I've seen some stuff that he's, shared with me, some files and that I've looked at, and they do some photographing and videoing of some of what they've done, but is a lot of it is just the problems of the logistics of just getting to where they want to be to set the targets up. It isn't so easy, I guess, doing these footpaths or doing the hiking on foot.
Yeah, 3. Well, like he said to us this morning, he's only ever been to that middle bridge. So that's hiking all of that gear 5 miles down that canal bank.
Well, I don't know that they have to hike the full 5 miles. I think they can drive to within, a mile and a half or more. Or maybe.
Yeah, but he said this morning he'd only ever been to that Walney Bridge.
Yeah, the 5 mile one was the first time this last weekend. I guess also he has problems dealing with nettles.
Yeah, well, it's like even if he goes to the bridge at what's it called, Slopes Bank or something like that, he would have a mile to walk.
Yeah.
Even with all of that big kit.
And I guess what is it you guys call nettles? He was fighting those for a while.
Yeah, you keep going on about that. There's a big ridge that he surely would be able to walk on. But like I said, if he wants to do the
I think part of the thing is, again, this is the difference between how I would do it and he does it, is he's not trying to stick out too much when he's there. He doesn't want too many people seeing what they're doing,
But isn't this meant to be a big, massive test?
Well, on the day, possibly, of when he's doing the test, he just doesn't want, in the meantime, attracting too much attention.
He did say to us, though, that he'd let us know so we could go down there and help him with filming.
Yeah. But until, he's still in the preparatory phase, proof of principle and all that.
Yeah, testing. But it sounds like it's going good.
Yeah, I mean, he's getting there. I mean, we've overcome a lot of the problems. He had some trouble with some of the poles and the collars and the guying down and stuff, but
Yeah, but if
Both
it's gone good and he's done the test and he can see it over the 5 miles, then the 3 mile one, you don't need to worry about that. If he's got the construction,
Well, he did
of
the 3 mile
5 mile
one
and
already.
he's had it up
Yeah.
and he's tested it and he can see it. I mean,
Yeah. Well, he's done the 3 mile one first, so he knows he's got that down.
yeah, but you said he'd done the 5 mile one as well. I mean,
Yes, but he hasn't done them together. He hasn't put them up at the same time, which he needs to do.
Will it matter? They're both going up at the same time?
Well, it is for the final test. I mean, on the final filming and testing and making measurements, you want them both up at the same time so that you can line them up with the crosshairs.
Oh, both at the same time?
Yes.
Whoa, Rumpus can't do that.
Sure he can.
No, he can't.
Why not?
Rumpus can't get two things, one at 3 mile and one at 5 mile, both lined up in the crosshairs.
Yeah, he can.
Nah, he can't.
I've done it.
You're not Rumpus.
But I'm saying he's going to have. No, he's not going to do it by him. He's not going to do it by himself at that time. He's going to, hopefully have a lot of helpers.
Right, yeah, well, like I say, we'll go up there and record it and do all of the filming for him.
No, he's not planning on doing this himself. I mean, he's trying to get a crew, assembled so that the day of the test, he'll have some, person, a couple people at each of the stations and at the auto level at the bridge, and so I think he's probably going to need more people than he thinks. He thinks he can do it with 5 or 6 people. I think what he's trying to do, and given the logistics of it, he should probably have 9 or 10 people, but we'll see.
Yeah, he should have a project manager.
Yeah.
Yeah, I don't think Rumpus could do it. I don't think. But I mean, hey, yeah, it'd be great. I think it will.
Yeah, well, I wish him well. We'll see.
Yeah.
He's hoping.
So, is he going to measure the heights of the that's the bit that I'm more interested in, the technical procedure, where the Rumpus can measure the height of the. How are they getting that height of each of the marks? Because I'm taking that's what it's not good enough just to line the crosshairs up with the thing. You have to get some data out of it, right?
Yeah. Well, you'll do basically what I did. Is all you have to do before you set up the targets is measure the center of the targets on your poles. When you have it assembled before you raise the height up. Excuse me. Is you have marks on your poles, say you could put every 5 feet if you want, or 10 feet or whatever, to the center of the target. Then you don't have to measure then to the center of the target. All you do is measure to one of the marks if you know how far the mark is from the center of the target, right?
Yeah, but you've got to measure how high it is from the water, right? You've got to reference all of these marks and the auto level to the water.
Right. Yeah. In that case, of course, that's going to take a little more doing, because then you have to sight a level line over the water to which you can measure the drop distance to.
Yeah, individually.
Right.
And I know that anyone can look through an auto level, right? But actually being able to measure the height of the water and your auto level and the height of the post.
Yeah, that takes a little bit of doing.
Yeah.
Yeah.
As he practices.
Yeah, it's not going to be a walk. It's not going to be a walk in a park,
Yeah. Has he practiced any of that?
That I don't know. I would hope that he had.
Because that's a bit more technical, the way I see that.
But again, you don't have to get it down to, millimeter levels or millimeter scales or anything like that.
Do you not?
No, I mean, if you're looking for, say, drop distances on the order of, say, 20 feet or whatever, so what if you're off a few inches,
Well, isn't that the whole thing that you're meant to be measuring?
Yeah, but if you're, say, 20 feet is 240 inches, if you're off by, say, 2 inches out of 240, that's less than a 1% error. That's acceptable.
$20.
20 feet is 240 inches. So if you're off by 2 inches, that's less than 1% error.
Yeah. But is that what you're after?
Well, of course, the better the accuracy, so much the better. But I mean, I'd be happy in a case like this to be within, 5%.
Okay, because this is the drop of the water level. Is he doing reciprocal, or is that a bit too much to ask?
How are you going to do reciprocal? You're just looking forward in one direction from one mounting point.
Yeah, that's what I'm saying. Is he doing reciprocal or not? No.
Well, to get that all done in one day would be nearly impossible, Bev. Trying to change the auto level and the target positions. I mean, you're talking a 5-mile stretch, and if it's taking better part of a day to just get the one setup done, you don't have a prayer, swapping things.
Yeah. Well, how are you going to know that the water level isn't just sloping one way?
Or can't. Well, it's impossible for an auto level where the compensator is moving freely to have a bias.
Yeah, I'm saying the water's dropping though, right? That's what you're trying to measure.
Yeah.
Yeah, so how do you know at the end, or how's Rumpus going to know at the end of the day that the water's not just dropping one way? How do you know that slope?
If it was dropping one way, it would be flowing, wouldn't it?
Well, you get an auto level, and you're measuring a drop, right?
If you're measuring drop from a tangent, not elevation. It's not an elevation.
It's an auto level. Yeah. Because you're measuring a bigger distance from the crosshairs to the land underneath, right? That's what an auto level does.
Well, the auto level is just sighting a horizontal from its mounting position.
Yeah, and then when you put a measuring stick in it, you measure the distance to the land underneath. And if that distance gets bigger, then the land drops, right?
Yes.
Right, well, that's what Rumpus is doing, right? He's got a big 30 meters,
that's right,
30-foot stick.
That's right. Yeah. Yes.
So how do you not know that the water is just dropping in one direction?
I guess I'm not quite understanding what you're asking here. I mean, I guess I'm not on the same page here.
Rumpus is using an auto level.
Yeah.
To measure the drop of the water level over distance.
The drop from the water.
A drop from horizontal, from the auto level, right? The tool that's establishing a horizontal. And your Rumpus is going to be measuring the drop of the water level.
Not up the water level.
Over distance. Yeah, because you're referencing all of these points to the water, right, in the canal.
The auto level remains fixed in one position.
Yeah.
Okay. You're shooting
on
a
the
horizontal.
canal bridge.
Yeah.
Yeah.
It's on the bridge. You're shooting a horizontal from that bridge.
Yeah.
And now what you want to do is measure the drop from that horizontal line that the auto level is giving you down to the surface of the water, correct?
Yeah. That's what you say Rumpus is doing, right?
Yes. Mm-hmm.
Yeah. Yeah, that's why he needs a big 30-foot stick
At 5 miles, yeah. At 5 miles, theoretically, at 5 miles, your drop would be 25, say 200 inches.
And so that's a drop of the water level, right?
Drop from horizontal.
Yeah. Of the water level.
I don't know what you mean by of the water level.
Because it's the canal water that you're measuring the drop from, right?
Sorry.
You're not measuring a drop to the land. You're measuring a drop to the canal, aren't you?
Please. Sorry. I guess I wasn't listening carefully. Are we talking?
Is that his mic or is it me? I don't know. You seem to be cutting in and out, George.
Yeah. Sorry, I'm just kind of tired here.
Now playing this.
Just a minute. But I think I've been hearing two different things. Are we talking auto level or water level?
Right.
Both.
You are at Bedford Canal, right? At the old River Delph.
That's what I'm assuming.
He's on a bridge.
On a canal.
Welney Bridge. Yeah, it's called the canal. Yeah. So he's on the bridge.
A canal and you've got a bridge over the canal.
Right, and then he's going to measure the height of his auto level from that water in the canal at the point he's at, right? And get us a number.
Correct. Okay, let's call that D0. We've got the drop distance D0 from the center optics of the auto level. Its crosshairs to the surface of the water. We'll call that drop distance D0.
And the auto level is establishing, it's set up, it's been calibrated, and it's a perfect one. We've done our 2 peg test to make sure that it's working, it's all functioning in correct order as it should be. And it is establishing a horizontal and looking out over that canal, or just to the right a bit, right where he's got his post set up.
Yep.
Right. Now, he's looking out with that horizontal, and what you are going to be doing is sighting targets, right? Now, those targets...
You're going to adjust the target height so that the center of the target will line up with the crosshairs of the auto.
Right, and then you're going to measure from that to the surface of the water.
Correct.
Right, so
call that drop distance D1. Okay? So we got D0 and we got D1. Now,
you're going again, George. If you got a bad connection there on your mic or something, it's going. It sounds fuzzy.
Okay. Well, I can't do anything about it because it's an internal mic on my laptop.
It sounds good like that. He might be sitting back or something, right? So So let's call that the 5 mile one, right? Now, if one distance that you're measuring is greater than the other, D1 is greater than D0,
then it is not flat.
Right, now, is that a drop of the water level or a rise of the horizontal? Which one of those? Because I think they're the two options, right?
Yeah, okay. We have our 2 measurements. We have D1 out at 5 miles, and we have D0 at the auto level.
Yeah.
Now, if we subtract D0 from D1, that difference is the drop due to the curvature of the earth if it exists.
The drop of the water level.
Okay, if water level, okay. Yeah. Okay.
So that's what I was saying. He's only doing it one way. So there's no way of us knowing whether that drop occurs in the other direction or not. It could just be a one-way drop, right? It might rise if you look the other way, right?
Oh, no, it can't.
What do you mean it can't? We don't know, though, because we're not doing the reciprocal, are we? I mean, it might.
I can't see how it possibly could.
How it could possibly rise.
Yeah, because then you would have a slope and the water would be flowing.
Yeah, that's why you went for the drop, right? We know that. That was cited. It was PNS that said that today. He cited your the drop of the water as one of the best globe proofs that we've got, that you've got. And I'm guessing this drop that Rumpus is going to measure is going to be a good globe proof, right? Drop of the water level sounds like a good one.
Yeah.
Uh-huh.
Well, it's just doing a high-tech version of the Bedford level that was done, in the 1800s.
No, he was at the water level, though, wasn't he? He was 8 inches above. Or was there a different one?
No, I'm talking about the Wallace test where they used flags in a boat. They're basically the same sort of thing, but done on a higher tech level, higher tech scale.
Higher height, right? Because where was the guy on the...
Yeah. Yeah, you want to be up as high as you can be to get out of the near zone refraction just above water, which tends to be problematic. That's why, like I do my tests, my on-level and theodolites are always mounted at the observation point about 12, 13 feet above the surface of the water or ice, is to get out of that refractive zone.
Right, well, what do you reckon about the original Rowbotham one, then?
Well, they were using boats and stuff, so they were close to the water.
Yeah, he was in the water, wasn't he? What do you reckon? Yeah. Do you reckon he could have done that?
So they would have been subjected to a lot of refraction under those conditions.
Yeah, do you think he could have done it?
Not easily.
6 miles at 8 inches above the water.
No, you'd never see the flags over at 6 miles.
Yeah, I say that. Like, he'd never do it. It was a load of bullshit, right? It never actually happened.
I don't know. I haven't really studied that test. All I know is a little bit about what people mentioned about it. I haven't really studied that Rowbotham-Wallace test. Or not Rowbotham, but Wallace, and who was the other guy? Was it Rowbotham?
I don't know. Rowbotham was the one that did the 8 inches above the water.
Okay. Yeah. Yeah, I think those tests were probably problematic and, really couldn't be trusted necessarily.
Yeah. Yeah, I don't think that's possible. Have you ever seen any shots over that sort of a distance of water from like 8 inches above the...
I've tried, but you just don't see much.
Yeah, how far do you reckon? How far? What's your best distance?
I can't really say. I haven't really tried to do it rigorously. All I did was, just some quick observations to see what I would get, and I just found that, there was just too much blurry haze and stuff due to the immediate moisture just directly above humidity and moisture just directly above the water, Yeah.
Do you reckon, how many studies do you reckon that have been done?
I don't know. I mean, nobody in his right mind would be trying to do these sorts of tests only 8 inches above the water.
But that's the historic one, right?
Yeah, I said nobody in his right mind would be trying to do it that way. I mean, we know a lot more about the characteristics of the optical zone directly above water than they did 100 years ago.
I know. Like, imagine the optics that you had back then as well. Like, do you reckon those optics have got better?
Oh, yeah. Yeah, I mean, the glass that we have now is much clearer and purer than what they had back then. I mean, we can really make superb optics these days.
What do you reckon his zoom he had in his telescope, or, well, magnification? Wouldn't have had zoom, would he?
I don't know what they used then. I mean, they did have telescopes back then, spotting scopes and stuff, but of course they're not near the quality and grade that we have these days.
I know. 8 inches above the water as well. Looking. I'm not too sure.
Well, I mean, that's an ancient test. I mean, I don't know why people keep quoting that test or that. I mean, it's so crude compared to what we can do today.
Yeah. Well, I mean, it seems like he did it, though, right? That was the one that was supposedly successful, right? It was the second one that they got to court and do all of that bullshit, right?
Yeah. Again, a lot of these sorts of things, when they were first done, I tend to kind of dismiss them. I don't put a lot of weight on early tests that were done, 100, 200 years ago or so. Some of these guys were very clever. Some of these experimentalists like Faraday and Coulomb and others, when making measurements on electric charge and stuff, they had some pretty sophisticated apparatus, and even Cavendish with his gravity stuff, he had a lot of money he could throw at it, and they made some pretty sophisticated apparatus, but not everybody had that luxury. And this Robotham or Wallace test on the canals, I mean, that was pretty crude compared to what we're looking at. I thought
you were the refraction guy, George. I thought you'd be the guy on this. Or is there somebody else that does the refraction? I'm just wondering, the original study for the 8 inches above the water, how much has anybody ever studied that particular thing for Bedford to try and recreate that historic?
Well, why would you want to try to recreate it with the same problems that they had? I'd say you want to be.
What problems did they have? I mean, who studied it to find out?
I mean, it's very well known. The refractive characteristics of air just above water are very well known these days. It's been studied.
Yeah.
And not only is it refraction that's a problem, it's just that your viewing is limited because of the haziness that you pick up with all the moisture in the air.
Oh yeah. We have done studies on that sort of stuff, particularly with the auto level. We've not really done it over water because who do that shit over water, right? But we have checked the optics of the auto level and see what happens over distance, and how accurate it can be over the certain distances.
Yeah, not only
we've never done anything as ridiculous as 3 and 5 miles just yet. I mean, that's proper out of the working range of an auto level, right?
No, it isn't.
Of course it is. The working range.
Huh? Well, hang on a second. That is, not only do you have a problem immediately beneath the water with the humidity and refraction, there's the issue of visibility, and temperature differences. You have dramatic temperature changes from the surface of the water into the air just directly above the water, So you can pick up tremendous amounts of refraction in that zone of a couple feet between the surface of the water, above the surface of the water in the air because of the dramatic temperature changes. Temperature differentials are the primary driver of refraction.
Uh-huh.
Humidity.
So some of the stuff that Rumpus is going to see might not actually be the drop of the water. Is that what you're saying?
No, we're getting into something else. What I'm saying is directly above the water, why you want to be at a significant distance above the water. Significance to me is, a couple meters or more, 2-3 meters above the surface of the water. So you're out of that temperature differential zone above the water that can cause, a lot of refraction.
Is that why Rumpus is just using the canal as a benchmark for his measurements, right? Because he's not actually doing the test over the water. He's just using the water as a benchmark.
I guess you could say that. Yeah, I mean, his actual targets are not directly side bank, and then he'll measure over to the surface of the water by, sighting a level line from the target, so to speak, over to the water, and then measure drop down.
Right, so the water is going to be the standard that we're using.
Exactly. The water establishes a reference.
Okay, so what does the auto level do then?
Well, I guess you could say you have two references, two stable references that one is going to be the surface of the water, and then the other is going to be the horizontal established by the auto level.
But the crosshairs for the auto level are within the auto level, right? They're not 5 miles away.
No, they're in the optics. Yeah, they're etched into the lenses of the auto level.
I don't think that's a horizontal over that entire distance, though, that the auto level can see.
It is. It's just optics. It's just optics. It doesn't. There's no limit as long as you can see in the distance. There's no limit. I mean, the horizontal doesn't deviate.
Well, because it's in the cross. It's literally inches away from your eye. I mean, how is it going to deviate? It's right in front of your eye. It's just a little mark on a little plastic bit that they drop into the level.
Well, it's actually more than that. Is the auto level, the optics of the auto level float once the compensator is released. It has an internal compensator that essentially, in principle, has a plumb attached to it, and it floats it so that you can move the base around a little bit, and it won't affect the horizontal sighted by the auto level.
Stabilizers and all of that. We've got all of that. In fact, I'll put a thing up.
Because once you hear the compensator release, you could pick up the auto level base, say a fraction of an inch, and drop it, and you'll see that the crosshairs move up and down. They'll bounce around, they'll oscillate, and then they'll settle down to the same spot as you had before.
Yeah, there's an auto level with all of the stuff in it.
Yeah, that's why they call it an auto level. It's independent of operator setup. Is once you get the bullseye level on the base, the bullseye bubble centered, and the compensator releases, then it operates independent of anything that you do as an operator.
Well, that reticule, it's just a sheet, isn't it? That is within the auto level.
Well, it's etched into some glass that's between the lenses in the auto.
Yeah, it's there in the drawing, right? That's where it is.
Yeah, it's in the optics of the auto.
Okay, now, like way off in the distance, like you said, the image of the thing that you see is affected by temperature and all sorts of refraction and stuff. So the little reticule, So that actual reticule that's inches away from your eyes, isn't necessarily a horizontal that goes through all of everything that you see with affected by the temperature and all of that sort of stuff as well. I mean, it will still be horizontal because it's in the auto level. But do you relate that to something that's 5 miles away?
You kind of got it backwards here, Ben. The horizontal is there because of the auto level. What changes is the image in the distance due to possible refraction. That can move up or down, but the image can move with respect to the horizontal. The horizontal is fixed. Your optics at the auto level fixes your horizontal. Now, the image in the distance, because of air refraction, can move relative.
Oh, you're going again, George. It sounds like you're underwater. Yeah, your connection's going pretty bad.
I don't know. I can't. Hold on a second. I'll be back in about a minute.
Okay. Thank you. Sounds bad. It sounded like he was going underwater. Was that for everyone? It wasn't just for me, was it?
Yeah, he was kind of going bad.
Like the optics are within the lens or within the auto level. It's like literally. Let's see, they've got the eyepiece and then the reticule is like literally the next bit. And then you've got to look through the light, right? So all of the lens goes through the prisms and the focusing. And it's got the horizontal light ray entering the lens. And then just going through the reticule right at your eye.
Are you still there?
Yeah, still here.
Okay. We'll see if this works any better. My throat's real dry. I'm gonna get a drink here.
It does sound much better, that, George. Is that a different mic or something? It does sound much better.
Oh, is this any better?
Yeah.
Yeah, my throat was getting real dry. Okay, what I was saying was that the horizontal established by the auto remains fixed. That doesn't change. What can change, is the image that you see in the scope in the distance, because that image can move up or down due to refraction. And depending upon how much refraction you have will determine, how much the image changes. And what I found in my measurements, I've been monitoring my targets.
Oh, you're going again, George. I don't know what happened then. Did you kick something?
Nope, haven't changed anything.
I could hear half of what you're saying, and then it just went the second half.
Discord has always been a problem. We probably get on Skype and it might be better. I've never had Skype.
No, we don't do Skype. Sounds like your mic or something, to be honest with you.
Oh, it could be, like I say, is I'm just using this laptop that I recovered out of the fire. It's not 100%. All my computers except for this one laptop got all burnt up to a crisp. I wonder here. Let me see. Just check my Discord settings on voice and video.
Oh, well, how much does he factor in for the attenuation of the light?
Attenuation of the light shouldn't have anything to do with it, just on your ability to see things.
In the distance?
Yeah.
No linear attenuation? Vertical?
I'm not sure what you mean by that.
Rumpus, you're not... in the mechanical help you've been giving him, you didn't give him any help for any of that sort of stuff.
I don't see where that is an issue. I mean, all you want to do is make sure you're on a nice lit day, you know, with maybe sun out, not heavy overcast, so that you can see things as long as the lighting's good.
Are you not allowing for any of the temperature or anything from the water?
There's allowances for temperature, whereas there's a temperature array I've helped them with, thermistor array, where it'd be measuring temperature along the optical corridor.
Nice. And no factoring in for anything. It's all going to be the drop of the water level.
Yeah, and then you go back, and then you determine how much refraction there was, to see if there's any corrections that need to be done.
What you do post corrections for refraction.
Well, you can't do it on site. I mean, you have to take what the air gives you.
Okay.
I thought there was like an attenuation you had to account for, because that light's passing through a medium, so you have to account for the.
Not the attenuation. All the attenuation does is affect the brightness of targets in the distance. It doesn't affect their position.
Oh, I just would assume you'd have to account for it. Yeah.
What do you have to account for? I mean, if you can see the target, you're done.
You don't need to account for the horizontal attenuation, though, do you? Just the vertical.
What do you mean by vertical and horizontal attenuation?
The vertical and horizontal.
No, You
don't have any.
I think you're using the word correctly. Attenuation just means how much does the light lose its intensity as it comes to you from the target.
Yeah.
Yeah, it would be passing through a medium and losing the attenuation.
If you can see the target, it doesn't matter.
What happens if you don't see the target then?
You guys are talking at the same time.
What happens if you don't see the target or you see too much of the target? Would you factor any in then?
If you don't see the target, you can't do the measurement.
Could you not just say it's refraction and the vertical attenuation?
Attenuation
Didn't allow the light to get there.
Attenuation and refraction are two different things. They're not linked. They're not coupled at all.
They're nothing. They're not even related to each other.
No. Attenuation has to do with the brightness with which you see something.
Not the position of something.
I don't think your concept or you're using attenuation. I'm not sure what you mean when you're.
Are you sure it's not you?
I know it's not me. Attenuation has to do with the intensity in which you see something, brightness.
I thought they accounted for like light passing through a medium. There'd be an attenuation, either vertical or linear.
That's not what attenuation is.
Yeah, I've seen things where they measure light attenuation through a medium.
Attenuation has to do with how much an object or how much light is absorbed by the medium, which results in the brightness in which you see something.
Yeah.
You got just listen to me. Just listen a second.
Wow, George.
Go ahead. Sorry.
Yeah. Wow.
My bad.
Say you have a target in the distance. You have a nice,
like
clear,
5 miles
sunny,
away.
Jesus. Yes, in the distance, 5 miles. You have a nice, clear, sunny day.
Yep.
You can see you have a white target. You have the sunlight showing on that target. It's going to stand out. A nice, bright, sunny day. Now, let's take a cloudy day. it's not going to be so distinctive. Let's say you have now a little bit of haze or fog. No, it's going to be very, very dim. That's what attenuation is. Attenuation is in the foggy, hazy day, you have a lot of attenuation of the light. That is, the light intensity is dissipated. It is
by
reduced.
the clouds. By the clouds in the sky, stopping the light from getting through.
Yeah. And so you don't have as much light shining on the target, so it is being attenuated.
But yeah,
now,
I think Buster was talking about the attenuated light from the moisture content.
Yes, I was just getting to
in
that.
The air, not the attenuation from the clouds up in the sky.
Will you fucking listen? I was just getting to that. That's what I was talking about.
Vertical.
Oh, Jesus.
Vertical attenuation, not the air.
Can't I speak? Can't I speak?
Of course you can. We were just trying to get some clarity, though, Judge. All right.
If you're in a medium in which there is a lot of attenuation, for example, a hazy, foggy day, the light is going to be absorbed by that moisture, by that. So that is what we say the light is being attenuated. It's being reduced by the fog because the fog is absorbing the light. That's what is meant by attenuation. Now, when you say vertical and horizontal attenuation, I have no idea what you're talking about.
You don't know what vertical and horizontal are, George? Well, I can tell you. A vertical is like a plumb bob, and that goes up and down. And horizontal is like the side to side on a plane. George.
But wouldn't you
I'm
have
surprised you didn't know that.
If you were horizontal, Jesus fucking
George,
Christ,
your mic's going.
Stop this nonsense. Of course I know.
Your mic's terrible, George. You can't hear what you're saying.
Okay. All right. I'll see you. I'm out of here.
Well, sorry. Are you going, George? Your mic sounds terrible. Sorry about that. Sounded like you might have been shouting in the background there, but I couldn't tell. It was about the time that you said you didn't understand what vertical and horizontal are.
I did not say that. I said I don't know what you mean by vertical and horizontal attenuation. Of course I know.
Oh, I didn't hear the attenuation bit at the end of it. George, your mic's terrible.
Okay. Well, there's no point continuing then if I can't communicate.
Well, yeah, if you don't know what vertical and horizontal are.
Jesus,
we're not going to be able to communicate that. It sounds like you lost a lot with your house.
Bev,
George.
quit trying to insult me.
What, sorry?
I said, stop trying to insult me. Of course I know what vertical and horizontal are.
Well, I was just wondering because if it's over like a 5 mile distance, it seems like the linear attenuation over that distance would be a factor.
It's not going to change the position of objects in the distance. All it's going to do is make them lighter or darker.
Yeah, Buster, it's not going to make the water drop in the distance, is it?
It's not going to affect the drop distances. It's not going to affect the position of the objects or the image. The image isn't going to be distorted. All it's going to do is
it's not going to make the water
drop.
Yeah, it's not going to affect the water. We're talking about the vertical. The image.
Okay, if the image shifts in the vertical, that has nothing to do with attenuation. That's due to refraction.
Okay. And how much refraction? Oh, you do that post?
Well, it depends on the day, what the temperature gradients are. That's why you have a thermistor array to measure the temperature so that you can assess the degree of refraction.
And how many of those stations do you have along the way?
I think if I remember right, Rumpus was going to make several temperature arrays so that there's at least one at each post. and then maybe some spots in between.
Oh, yeah, here's one we had today. You know, when you're looking, you're setting your auto level up, and the horizontal that you, the crosshairs, they're just at the auto level, right? That horizontal is just at the auto level, like where that.
Yeah,
I don't know, where do you say the horizontal? Is it at the reticule? Or is it sort of the horizontal at the pendulum? Where would you have the horizontal within the
It's all set up so that the crosshairs, the horizontal crosshair establishes your horizontal.
Yeah, but that doesn't go all the way for 5 miles, that horizontal,
Yeah,
does
it does.
it?
Sure it does.
No.
Yes, it does.
Well, all the way, 5 miles horizontal.
Go 100 miles, 10,000 miles. As long as you can see in the distance, that's the horizontal.
Are you sure?
Yes, positive.
How big it would be your biggest horizontal plane that you could make?
I'm not sure what you mean.
Like
how big?
It's the auto level, as I understand it, establishes a horizontal plane of reference because you can spin it round, can't you?
Yeah, 360 degrees. You can make the whole plane if you want.
And that would be an entirely horizontal plane.
Correct.
Right, now, if you set up that horizontal plane, would all the perpendiculars to that horizontal plane be vertical?
Yes.
All of them?
Yes.
As in Euclidean. I'm so good to hear somebody like says that. So when we have all perpendiculars to a plane will be parallel. That you good with that, right?
Yes.
Right, okay. And if it's a horizontal plane, then all of those perpendiculars will be vertical?
To that plane, yes.
Yeah. Good.
But not necessarily to the Earth.
Just to the plane?
Just to the plane.
Yeah, that's the Euclidean principles that we work with. That's good. It's good to hear somebody like that, George. You've definitely shown that you've got a bit of experience with these tools. Should hear what some of the people have been saying recently.
Basically, when you spin your auto level around, you're sighting through the scope where you're looking at the horizontal crosshair. As you spin it around, it would be just like if you took yourself a sheet of plywood, a big sheet of plywood, cut a hole in the middle and stuck your head in there so your eye level was at the surface of the plywood and you looked around. It establishes your horizontal plane.
Right. And that horizontal plane will be parallel to the horizon, like everywhere you looked with it. If you did that, if you were to walk around with the plywood sheet,
I guess you could
with
say
your head
that.
sticking through it.
Yeah, I guess you could say, yeah, that would establish your horizon in a sense, except for the dealing with.
And you could constantly walk around everywhere with that.
A different story.
Oh, your mic's gone again, George. You're not even lighting up green.
I still think if you factored in the linear attenuation, it would give you another factor to tell you how much moisture is in the air. Just my opinion.
Hello?
Hello? I just heard you.
Yeah. Let me see here. Hang on, Bev. Let me see if I can tweak this thing again. What sensitivity?
I like the idea with the plywood nose band. I don't know what you call it. You can fit it like a pair of glasses just on the edge of your nose, and you could walk around with your plywood sheet.
Last part, are you hearing me now?
Oh, was that you, George?
This is me. Are you hearing me or no?
That's good now. There, yeah. Whatever you do, don't move.
I'm trying not to. Okay. So far, so good. Something you said that you against. Now, you've got your head in this hole in the plywood, and you've got your eye level at the surface of the plywood. That establishes your horizontal plane. Now, if
Providing
you
it's
move,
horizontal, right? Providing you level it up.
yeah.
Yeah.
Now, if you move around and you walk,
Oh, you've gone again.
changes. That plane, say you move. Okay, you start at point A, and you level your plane where you're looking around on the sheet of plywood. Okay, at position A. Now you move a mile away to position B. You do the same thing.
Yeah.
This is where you're going to have a problem. Is that plane, position B, is not going to be parallel to position A.
What I was saying is, could you not walk from A to B, keeping the horizontal in your eye line with your nose plywood sheet there? Would it not be all the way along, parallel to the plane of the horizon all the way?
You could, but
it would hurt your nose. George, we can't really hear what you're saying, George. Your mic's bad. Keep an eye on it. You can see that your green thing you're going.
Yeah, I don't. Because I'm sitting in the chair with my hand holding my head in the same position. There's nothing more I can do.
Right. Well, it does
I'm
keep.
sorry. My computer sucks. Okay, I get that. It went through a fire. It's actually melted down. So, it has some issues.
Definitely got issues. Oh, it's
I
gone.
don't have an external mic anymore. So.
I can't really hear what you're saying, George, but I do like the horizontals being parallel to the plane of the horizon. I like the nose plywood
I did not
sheet.
say
That's
that.
very
No,
good.
no.
Yeah, you did. You said the horizontal plane that you put on your eyes is parallel to the plane of the horizon. Always.
As long as you stay in the same position. But
no,
if
when you can walk around with it.
I was trying to explain that. And you told me my mic was, so I couldn't finish.
I can't hear what you're saying, George.
Okay.
Are you saying it's not parallel to the plane of the horizon wherever you are?
Not in that sense.
Well, you can walk around with it all the time, and wherever you look at the horizon.
Yes, Ben. To explain.
Sounds like you're trying to interrupt me, George, but I can't hear what you're saying. It's pretty bad. No.
Give me 5 minutes. I'm going to shut this computer down.
Okay. Do you like that? I think there's a new way of doing that. That's quite a good explanation he's give us there with the horizontal noseboard plywood sheet 8x4. Put a hole in the middle of it. I suppose you'd have to get some braces or whatever, shoulder pads. It'd like sit on your shoulders heavy, wouldn't it? Make it hard getting through doors. But I suppose you could teach people about the horizon being horizontal, especially if you were to put like a level on it, on each corner. Right, on it, put a level on it. I mean, you'd only need to, wouldn't you?
Well, you could for sure get sponsorships, and they could put their logo on it. That's for sure.
Like, yeah, I like it. Get some braces. You could get get somebody to help you with the braces. You get a level, like a DeWalt 4 level, and then a side level, a port. Is that port to the side? You get a level on that and a level on the other one. You'd have to keep it level, adjust your levels, and then look at the horizon. Slide it round 90 degrees, check your levels, look at the horizon. Check it out. I like it. In fact, you could put a static booth up, right, with your 8x4 sheet, level it all up, and ask people if they want to put their head through your hole.
Oh, the good old glory hole.
Just to your eye level. Just poke your eyes out there. Look, check that out. Parallel with the plane of the horizon. Could call it a horizontal attenuation checker.
Yes, I like it.
Have a scale. Brightness scale.
Or a template.
He got triggered over the attenuation. I didn't mean to get him upset.
But he must be thinking about the other attenuation.
I know. Wrong attenuation.
Semantics, but...
We definitely need a linear attenuation because, 5 miles of attenuation, that's got to account for something.
Yeah. Yeah, if it's there at all, then it would definitely be linear.
You got to factor in the shit. I forgot it now. What was it? Shit. Forgot the other term. Oh well, I'll think of it in a minute. Extinction coefficient.
That's it. The extinction coefficient of the linear attenuation. Yeah. That might be the bit that we missed out earlier. George might be thinking of the other attenuation for that reason.
Maybe. It's easy to get confused. There's a lot of things to factor in.
Is that crickets?
Yeah, my bad.
They're bloody loud, them buggers.
Yeah, they're getting louder the later it gets.
I was out doing the gardening the other day. Same thing. They're out in the UK, little tiny ones. It's good to hear, though. Getting late.
They're not. Yeah. He was enlightening with the test. That was pretty good.
Yeah. Knows more about it than Rumpus. He might just be a better speaker. It might be Rumpus gets shy or whatever talking about his test.
Definitely knew more than the guys today.
Yeah, it might be. Rumpus might just get nervous when he, talking about his test. I could probably put these two the other way round, right? Put this one first and then we could lead up and go. And now Rumpus explains his test. I'll do it that way, or I should do it the other way around.
Yeah, you could do a Rumpus v. George test explanation.
Yeah.
Hello. Is my audio coming through okay?
That sounds a bit better, but I don't like saying that, Judge, because normally when I say that, it goes really bad again straight away. But
I don't know. It could have been that the computer just needed to reboot. I don't know. We'll try it.
It does sound a little bit better.
I was hoping I could use my Eiderall as a mic, but I see I don't have the patch cables that I need. I lost all my cables in that freaking fire. Anyway.
Have you heard about Sean as well? Sean Hawkins. He might be leaving. He's not having a good time of it in the minute either.
What about Sean?
Have you ever used Sean's videos to give to somebody?
No.
No. See, nobody does. Why does nobody like Sean? I quite like him, although he does.
I didn't
he
say
does
I
call
didn't
people
like him.
liars and all of that.
I
know, but nobody watches his videos and stuff like that. You guys.
Oh, I've watched some of his
You guys
videos,
don't support him or anything.
No, that's not true. I was watching his videos and commenting yesterday on his videos. It's just that I don't pass videos around.
Yeah, well, we're decided we're backing Sean, especially with the Polaris argument. I'm not personally me. I'm not talking to anybody about Polaris unless Sean Hawkins is there.
Anyway, back to this horizontal plane thing.
Yeah.
Is now.
Oh, the eye hole, the head hole.
Yeah. Okay. So you're at position A, and you've got the thing leveled out, so it's parallel with your horizontal, or establishes your horizontal line. It agrees with the other level, let's say.
Yeah, we put a level on our plywood sheet.
Yeah. Now you move a mile away.
Yeah.
To point B with your plywood sheet. Your head's in it.
Yep.
And you set up your auto level and you align the sheet with that auto level. Okay. At point B.
Yeah, well, it's got levels on it. We've updated it, George. It's now got a 4 level, like a spirit level, and a side one as well. So if we can keep both of those levels, with the bubble in the middle, as we're walking, we can look at the horizon any time we want, can't we?
Okay. Fine. Yeah, that conceptually works. Okay. Let's say we have that. We have a very accurate spirit level. Unfortunately, they're very crude. They're not very. Let's just say, for sake of argument, that we have very accurate spirit levels on this thing, so it can maintain your horizontal. Okay?
Yeah.
All right. Now, when you get to point B, now if you were to draw a plumb line.
Oh. Yeah, you're gonna get
if you were to drop a plumb line from this,
we could have 4 from each corner, right? 1 from each corner.
Okay, all right. You drop your plumb line, right, at position B. Now, if you did the same thing at position A, being on the real Earth, this Earth that we're on, those plumb lines would not be parallel.
What do you mean? We've got a horizontal plane with our auto levels, and we've got a plumb bob hanging from each corner. 4 of them.
Right.
You're saying they wouldn't be, all of them wouldn't be perpendicular to the horizontal plane.
No. Still be perpendicular to the horizontal plane. The 4 plumb bobs.
They wouldn't be vertical. Don't be telling us we've got 4 plumb bobs that aren't vertical.
They are vertical.
Oh, and perpendicular to the horizontal plane.
and perpendicular to the horizontal plane. Yes.
That's nice.
But
so all perpendiculars to the plane
at a given position. At position B, all the plumb bobs will agree with one another. They'll be perpendicular to the horizontal plane, and they'll be parallel to one another.
Yeah, the
now,
one in each corner.
When
There's
you,
four
go
of them,
back,
then.
when you go to position A,
I'm liking
away,
this. This is a good
still,
one. You're helping us out tremendously here, George. I'm loving this. This sounds great. Because we've done away with the one vertical problem, and now we've got four from all hanging from the same horizontal plane.
I don't think you're listening to me. Okay, now we go back to position A. We do the same thing. Now all the plumbs at position A are perpendicular to the horizontal plane that you have, and they're all parallel to one another. The difference is if you were to precisely measure the plumbs at position A versus those at position B, those plumbs will not be parallel. That's the difference.
Okay, let's, seeing as we're walking around with our I-plane plywood sheet, can we extend that plywood sheet, the horizontal plane plywood sheet, from A to B?
Yeah, you could extend it indefinitely.
Okay, and then if we still have our plumb bobs, perpendicles, one on each corner, would they not be perpendicular to the horizontal plane?
To the plane that they're attached to.
Yeah.
They would not. If you go out far.
From A to B, that's what we said.
Yeah. No. Okay. Imagine this. Okay, you're onto something. Imagine this. You're back at A.
Oh, George, I know this is good. We're onto something here.
Okay.
But your mic's going again.
No. Okay. I'm sorry. Why it seems when I raise my voice a bit, it goes haywire. Now, okay, let's say we're back at position A. We have this horizontal plane. We've got this big sheet of plywood. It goes out several miles. Okay?
Yeah.
Right. So, we've got this flat plane that we're in the middle of. We've got our eye level at the surface, and we're looking out over this horizontal plane. Now, we take a plumb bob and we attach it just a few inches from our.
You've got one on each corner of this plywood sheet.
Plus, we have one in the middle.
Yeah. Okay. You could have them all the way along it, right?
Yeah, we could do that. Well, let's just say, for sake of argument, we've got one on each corner and one in the middle.
Oh, George.
Okay.
Yeah, your mic's going again, man. This is some of the best stuff we've done. This teamwork.
Okay, now, if we were to precisely measure the plumbs, all those four plumbs on this horizontal plane, they would not be parallel. They would only be parallel if they were close together. But the fact that they're separated by mile or a couple miles, they will not be parallel.
Are they all perpendicular to the horizontal plane? Oh, George.
That's where we differ.
So, sorry, I missed that. Are they all perpendicular to the horizontal plane?
Not if you've extended that plane out several miles. The ones in the corners will not be perpendicular to the plane anymore. Only the one in the middle, where your eye is, will be perpendicular to the plane.
So you're saying we've got perpendicles to a plane?
We got what?
We've got perpendicles to a plane.
Perpendicle.
It's a plumb bob hanging from. It's a weight hanging by a string.
Okay, sure. Mm-hmm.
Perpendicular.
Yeah.
But you're saying they're not perpendicular to the plane.
Not the ones in the corner. That's a long ways away from your eye. Only the one that's hanging by your eye will be perpendicular to the plane. The fact that you've moved the corners way out several miles, the pendulum...
It's still a horizontal plane though, right? Oh, you've gone again, George. Always when I ask a question for clarity.
Yes, the horizontal plane is established by your eye, and the issue is here, Bev, is the fact that you're moving the corners away from your eye by several miles. That now changes the gravitational vector that aligns the plumb. The plumb always will try to point to the center of the Earth, and as you move away from your eye, there will be now an angle from perpendicular pointing towards the center of the Earth. That's what the plumb's alignment says to. They don't care whether or not they're perpendicular to the horizontal plane. They try to point to the center of the Earth, and as you move away from your eye, they now have to point inward at an angle towards you, towards the center of the Earth.
Can I just get for clarity then, right? We've got a horizontal plane, and we have got some plumb bobs hanging from each corner.
Yep.
Right now, so that's a horizontal plane and a plumb bob that establishes a vertical. Right?
Yep.
Now, are those verticals perpendicular to the plane?
Only if they're close together.
But they're at the end of this plane that we've just established, which is, I don't know,
it depends upon
a mile.
how large. It depends upon how large this plane is. Now, if say
you're putting
around,
a size limit to a horizontal plane, are you?
Pardon?
Well, we did ask this earlier on, and you said that a horizontal plane would be infinite.
You could make it infinite, sure.
Okay, right. Mm-hmm. So the perpendicles or the perpendiculars to that horizontal plane, infinite horizontal plane, would be called what? The perpendiculars to a horizontal plane.
Well, the perpendiculars to the horizontal plane will be perpendiculars, but they won't necessarily be parallel to a plumb that's hanging.
But a plumb bob is a tool for establishing a vertical.
That's right. But how does a plumb operate? It operates that it hangs down where it's pointing towards the center of the Earth. That's called
it's going to be hanging down from the end of a horizontal plane.
I can explain this here. Hang on. I'm just drawing something in paint right now, and then I will post it so that we can talk about it.
Okay. I'll just have a word with Sugar Cookie.
Sure.
I've got a little attachment thing that you put on optical devices. It's for cameras and auto levels, mainly for what do you call it? Telescopes and stuff. But it's where you fit your phone to the eyepiece. It's got all sorts of adjustments on it, so you can put your phone over the eyepiece of any device that you want, and that's the best way that we do, because we pipe that phone picture then straight to Discord through I don't think I can. I think it's in the car, to be honest. My little doodah. It just fits your phone goes on one end and the other bit sort of tightens over the lens piece to make it so you can do it. I presume Rumpus will be having one of those when he does his with his auto level. You know, Ranty's getting an auto level. What do you reckon to him? Ranty, team Are you Team Ranty, George?
No.
No.
Ranty hasn't spoken to me in months.
Not even when he's come on over to your side, like?
No, I haven't spoken to him since he turned the show over to Brandon.
Oh. Well,
It's been almost a year. Yeah.
He's meant to be going up Winter Hill with it. He's getting an auto level. Ruhif's buying him an auto level, you know.
I didn't know that. No.
So he can he can join the ranks of the globe surveyors like B-Ball. The new breed, right? You've got B-Ball and Ranty. Right, move over, Jesse. Go away, guy
Jesse's
from
pretty.
Maine. Get out of here. We've got Ranty and B-Ball. Oh, and Bob as well. Did you hear it? That was a good one, wasn't it? That was brilliant with Bob. You don't need measuring rods. Magic sticks, I think. What was it he called it? Magic measuring stick.
Who is Bob?
Bob the liar guy. The one that
Liar guy.
Yeah, the one that said he measured the drop of a lake from his back garden.
Oh, I don't know who that is.
Sticky tape and crayons he uses rather than a
I'm going
measuring
to
rod.
post this now in the chat. Okay, you got that?
Yeah.
All right. Now, here we are. The black line, horizontal line, is our plane, is our big sheet of plywood on edge. Okay. In the center, we have our red head. And our eyes are lined up with the sheet of plywood. Okay.
Okay, that's our head in the middle there, is it?
That's our head in the middle. Yeah. Okay. Now, the red lines perpendiculars to the plane at any distance. Let's say the plane, our head to the edge of the plane is, say, 10 miles. Okay.
Wow. It's bigger than the board I was thinking.
Yeah, it's bigger. We'll make it whatever size you want. I'm just saying, just for grins, let's say it's 10 miles from the center of the head out to the edge of the plane. Right?
Wow. Yeah, 20 mile horizontal plane. 4
Correct.
feet wide will do, won't it? Right, we don't need to make it.
Okay, now, the red lines are perpendiculars to that plane. Everywhere I have a red line drawn, which is perpendicular to the plane. Okay? That's
so
the red lines.
If that's a horizontal plane, would you call those red lines then vertical?
I'm getting to that.
Okay.
Okay. Right now, we're just going to say they're perpendicular to the plane. Okay, we're not going to talk about them being vertical or not. Okay. Now, the blue lines are plumb lines. The blue line is a string, and the blue circle at the end are weight. Now, on the Earth, this is what's going to happen. Is only at the center where your head is will that plumb line be hanging straight down so it's perpendicular to the plane. Everywhere else, it will not be perpendicular. It will point towards the center of the earth. They're going to camber inward towards the center of the earth, so they will not be perpendicular. They are vertical. They are the verticals at that point, but you can see that the verticals are not coincident or are not the same as the perpendiculars. As you move away from the center where you are viewing, the verticals deviate from the perpendicular. And they deviate more and more as you get further and further away from your central point. That's the difference. That's where we get hung up.
That's
This
on your
is
model, though, right?
Yeah, this is for the globe Earth model. This is what happens.
On the model,
Now,
on your
if this
model.
was a flat plane, if it was a flat Earth, then everywhere on this plane, the red perpendicular and the blue lines would be parallel or dropping straight down. They would not be cambered inward.
Yeah,
If you were on a
everywhere
flat.
on that plane, the perpendiculars would be vertical, right? Horizontal and vertical.
That's
everywhere along that plane would
Yes,
be
everywhere
always
along
be.
there. Yes, everywhere along there, the blue line and the red line would be coincident with one another.
Yeah, the
They
vertical
would
and
lie on top
horizontal
of one
would be
another.
perpendicular at every point, everywhere
Yeah.
along that thing. Okay,
Yeah.
but only on one model and reality, obviously. Because in reality, everywhere you go, the horizontal and the vertical are perpendicular, aren't they?
Or the flat Earth, yes.
In reality as well.
No, not in reality. The reality is what I'm showing you here for the actual Earth, for the globe Earth.
No. I'm saying, in reality, everywhere, vertical and horizontal are perpendicular.
No.
Yeah.
No.
Yeah, I've never seen anywhere in reality where vertical and horizontal aren't perpendicular.
That's because you think. That is because when you move, how can I do that? I would have to do another plane. When you move, wherever you are in the center, this is what your reality is going to be, is seeing this sort of thing. And let me say this. I'd have to draw another picture. Here, hang on. Let me draw another picture. Oh, gosh. Let's see here. How am I going to do this? Just give me a few minutes here. I got to do another picture.
That's okay. I'm going to have to go and get some kip soon, though, George. It's 3 o'clock a.m. I quite like this idea, though. Sort of shows you about horizontal and vertical being perpendicular. Somebody's give you a thumbs up. Sugar cookie. You like that, sugar? It's a good globe model representation, that, isn't it? Horizontals and verticals. Is this another model? Are we going to get a
No, it's the same thing, but I'm going to show you what happens on the globe Earth when you move away. This is the part that's going to upset you greatly.
That first one was that was your globe Earth one, wasn't it?
Yes.
you're going to give us another one.
Okay, I'm ready now. Let's see. Screen. Okay. Here comes the next one. Okay. Now what we got here, Bev, is on the left-hand side, I just have the same thing as the first diagram we were talking about. Okay.
Yeah.
This is position A. Oops. Okay.
Yeah.
Well, here, hang on. Let me redo. I want to add something to that. No. And I'll blow that one away. Hang on here. Just give me a second here.
What did you do? You tilted the horizontal. You put an angle
Yep.
on the
Hang
horizontal.
on a second. All right.
Is there another picture coming?
Oh, shit. God. Damn it. Yeah, technical
Notice
difficulty.
Rumpus does that as well. Is that like a sort of a drawing thing that you do when you're doing your drawings?
Except I don't have as
yourself.
many problems as Rumpus. Yeah, I guess I've been listening to him too much. Becky, Hal! Here we go. That one. Put this one instead. Okay. All right.
Okay.
We have two positions, A and B, and we're separating them by 10 miles. Let's say where we move. We're in the center at A, and then we move our horizontal plywood plane to position B. That's 10 miles away. Okay.
Right. It's not horizontal there though, is it? On B.
But it is as far as B is concerned.
What?
See, the thing is see, this is where you have problems regarding the globe Earth model, if you will. If you're at position A, say at the top of the globe, your vertical, where you are in the center there, is straight up and down on your page. That's your vertical. Now, if you move to B 10 miles away, your vertical relative to A is going to be tilted a little bit because that plumb line hanging from B has to point towards the center of the Earth. The center of the Earth is fixed, and the line that you draw your position at A
perpendicular to the plane of the horizon, though.
But it is B's plane
wherever
horizon.
You are.
B's horizon looks different than A's horizon on the globe Earth.
Not to B.
Huh?
Not to B.
Yes, it does. They do not see the same horizon.
It's always parallel to the plane of the
But
horizon.
the thing is,
right?
the Earth is curved.
Horizontals for B.
The Earth is curved. That's the problem. That's why it changes. Is because of the curvature of the Earth.
Horizontal
if the Earth
changes.
And the horizontal changes. If the Earth wasn't curved, if it was on a flat Earth, the horizontals and the horizons would all be the same no matter where you were on the Earth. But on the curved Earth, they change according to position.
Yeah, but if you're like we were doing, walking around with that board parallel to the plane of the horizon whenever you're walking, it's always...
But your horizons are changing.
It's always parallel to the plane of the horizon, though, right?
Yes, but your horizons are changing as you change position. As you walk around.
As you walk and you move around. If you like walk towards the plane of the horizon, then all you are doing is walking towards the plane of the horizon. The horizontal that you have is still parallel to the plane of the horizon, even though you're moving.
That's right, but the plane of the horizon is also
every point
changing. The plane of the horizon does not remain fixed. That's
every point you're at. Horizontals will be parallel to the plane of the horizon, and verticals would be perpendicular to that horizontal.
Yes, but you're not listening to me. As you're moving around, the plane of the horizon changes. Even though you're remaining, you are indeed remaining parallel to that plane of the horizon, but that plane of the horizon is also changing as you walk around the Earth.
But everywhere you're at, everywhere, without fail, always parallel. Horizontals are parallel to the plane of the horizon at every point.
Correct. But the plane of the horizon is changing. But the plane of the horizon changes as you move around.
Well, yeah, because you're looking at a different place, but it is always parallel. Horizontals are parallel to the plane of the horizon.
Yes, but the plane of the horizon is also changing, so that the plane of the horizon at A and the plane of the horizon at B are not.
But this is why I think your horizontal plane with your head through it is such a good idea. Because no matter where you are, all you have to do is turn your head, and the horizontal that you've already set with the levels on it will always be, no matter where you're looking, it'll always be parallel with the plane of the horizon. You take one step further.
Correct.
Yeah.
Yes, that's correct.
And if the horizontals are all parallel to the plane of the horizon, then the horizontals necessarily must be parallel to each other.
No, that's where you're falling off the wagon. I just told you, as you move around, the plane of horizons are changing. They are not parallel. Planes of the horizon at point A and point B are not parallel to one another. Hence, the planes, your horizontal planes can't be parallel to one another because the planes of the horizon have changed.
Now, that's not the way I see the logic, George.
Well, I know that's not the way you see it, but just explaining, that's how Rumpus and I see it on the curved Earth.
Okay. Well, Rumpus this morning was speaking for 90-odd% of the people. Now you're speaking for Rumpus. I called Rumpus like he wanted to be a wannabe priest. Because he was saying he was speaking for all of his subjects.
Well, Rumpus and I understand the curved Earth and the spherical Earth. So, of course,
that's what I said to him. I said he wanted to be a globe Earth priest.
The sugar cookie doesn't quite understand a slanted horizon. the horizon at B is not slanted according to B's position. I could set, and I could rotate this a little bit so B is horizontal with the screen of your computer. That's what you see when you're at B. Relative to you, no matter where you are on the earth, you think you are in this horizontal plane. But when you move around on the surface of the earth, when you compare B to A, they are not parallel.
We do 1, 2,
because
and
you're
3.
going around the curved surface.
We do 1 and 2. Have you not heard? Like A, B, and C, they're old school. They're old.
He says, I get a drop, not hump. I'm not sure what you mean by hump. Is this SE Montreal terminology?
Yeah, George has the drop, right? Sugar cookie. You must know about George's drop.
Oh, B, if you look at B,
2.
at where your head is at B,
2.
It has dropped relative to the plane of A. Yes.
New school.
Let me draw another diagram here. This might help. Yeah, this might help. Hang on, just give me a minute here. Choosing the right color.
Yeah. Yeah, it's the Bislin hump, the Kozlowski Bislin hump.
Okay, here comes up another diagram. Okay. Between A and B, I've drawn a green line. This green line, I'm extending the horizontal plane of A out so it goes past B. What we call the drop is that orange line where B's head is. That distance from the green line to the black line at B is what we call drop distance from horizontal or from the tangent drawn from A. That's what we mean by drop.
Is that okay? So, would you say that angular difference between B and the extension to A is the meeting of two horizontals?
Yes. Yes. Now you're getting it.
So where would you measure the angle from?
Oh.
And what would you call that angular deviance, right?
Well, nobody really uses that as a measure. I guess one way you could measure it is by maybe drawing a line from your head at A to your head at B, and you'd have a little different angle. It'd be a shallower angle, but you could use that as an angle.
I'll show you.
Well, you wouldn't say that B is looking up to A because technically the head at B and the head at A are at the same elevation on the curved earth. They are at the same level or elevation. So you're not there. One is not looking up or down towards one another because they're both at the same elevation.
There you go. Right, see this. It's like, what would you call that angle there?
Yeah, I'm saying it's not a standard angular measurement. I know what you were saying, and I'm just saying there is no real term for that.
What, the angular difference between two horizontal planes?
Yes.
Because, like, how would you measure that angle from a horizontal to a horizontal?
Well, the way I would measure it would be this way. Let me draw that for you.
I mean, you look at your verticals, right? You can't use that vertical as a reference because that would be a vertical reference between two horizontals of different angular measurements, and you obviously can't say that it's perpendicular from the vertical, because I mean it's never going to be vertical if it's not even perpendicular to the plane that the if the vertical isn't even perpendicular to the plane that it's on, then might it be perpendicular to the plane that it's not on? Or, like, I mean, it's not surprising they don't want to measure that or give it a name. I mean, perhaps we could set up a competition or something. What would you call?
I'm trying to just a minute. Let me think about this. I got to try to think of what you would try to measure.
What would we call it? Bet Sugar Cookie's good at this. Horizontal to horizontal angular deviance.
Yeah, there you go. As good as anything.
Yeah. What do you reckon that? How many times have you measured them? What's the biggest horizontal to horizontal angular deviance that you've ever measured, George?
Never tried to.
You've never tried to? Just draw it.
It would be very difficult to measure because remember the Earth.
It's because it's not
angular
there.
Deviance on plumb lines on the Earth is 1 degree every 69 miles. So to pick up just 1 degree of horizontal plane deviance, you'd have to go 69 miles. It's going to be very difficult to measure.
Well, I think a water level establishes a horizontal plane. But you don't.
So if you're, say, going to separate by 10 miles, then you're going to only be picking up about 1/10 of a degree in change between the horizontals. That's going to be very, very difficult to measure. The Earth is huge, so these deviations are very slight over, reasonable distances, like 10 miles, 5 miles, or whatever. The changes are so slight, it becomes very difficult to measure.
Yeah, well, like all tools that are called level establish a horizontal plane of reference, don't they?
Yeah, but the thing is, with the spirit level, they're very, very crude.
Yeah, well, it's about a water level. You can make them longer, can't you? They're more accurate over larger distances.
Yeah, but the thing is, there are practical considerations in trying to make a long water level. Theoretically, yes, you could get very accurate with the water level, but I don't know if you've tried ever making a long water level. I've tried in the past, and it's very difficult because you end up with air bubbles. You either have to have a large diameter tube, say on the order of 3/4 inch diameter or bigger, so that the air bubbles travel freely throughout, because air bubbles
you don't want air bubbles in a water level, George.
No, you don't.
Yeah.
And if you use small diameter tube, it's hard to get those bubbles out.
Nah, no, it's not.
Yeah, it is. Try doing it over a mile.
Don't put the bubbles in it. That's the best way.
Well, there's always air entrained in the water, and if the water sits for a while, the air comes out of the water.
No. What's the biggest water level you've ever made, George?
I've done about 900 feet.
900 feet?
Yeah, 2 450-foot sections of black poly pipe, 3/4 inch.
Nice.
That's about 300 meters.
Well, we've got you beat, George. We got 2 400-meter ones. Well, I've
Yeah.
got one 400-meter. Spot on's got a 400-meter one as well. So there's 2 of us.
You've actually built it?
Yeah.
Really?
Yeah. Yeah, we
And
did.
you never had problems with the water oscillating back and forth and settling down?
No. We tested the shit out of it. Yeah, we did our big test last weekend.
400 meters.
Yeah.
What kind of pipe?
Mine, I've got 3 mil. He's got 5 mil.
What do you mean 5 mil or 3 mil?
ID.
Millimeters?
Yeah, mil. 3 mil and 5 mil.
Well, in the U.S., mil means thousandths of an inch, so you got to be careful.
Well, mils is millimeter.
Yeah, we say millimeters or mils. A mil is 1/10,000th of an inch in the U.S. So 3 millimeters.
That's accurate.
I find that hard to believe.
Sorry, you broke up again then, George.
I say 3 millimeters over 400 meters. I find that hard to believe.
You find what? It's hard to believe that I've got a water level.
That you can get it to work. Yeah.
Oh yeah, it works perfectly. Yeah, it did. It was brilliant. Really good test.
I'd have to see that. I'm skeptical.
Yeah. Well, we live streamed it, so if you'd have come back a little bit earlier, you could have seen it.
Again, yeah, I knowing from my own experience in building water levels, I'm quite skeptical.
Well, we've been testing it for months, and we've done the test now. I mean,
what happens, say you've got the water level established where you have your vertical risers.
Yeah.
Okay. What happens if you move one end up or down? What happens to the water inside?
It just finds its level.
Yeah, but does it take a while? Does it oscillate back and forth, or?
It doesn't normally oscillate back and forth. It just finds its level again, settles, readjusts.
Yes.
Yeah.
But the thing is, before it can settle down and readjust, it's going to pump back and forth.
I wouldn't say so. It doesn't really go back and forth.
It always has for me.
Yeah. Over what distance did you do?
Longer the distance, the more it pumps and oscillates back and forth because you have more water.
No, it just adjusts and works itself out. I mean, you've got to remember that 3 mil tube, I mean, it's not a lot of water in there, right? It doesn't take that much. There's a fraction of a mil, right? A milliliter.
Let's
tiny
see,
amount.
3 millimeters, huh? Inside diameter?
Yep.
Okay, here, hang on.
Keeps it cheap.
Yes, but there's so many problems with using small diameter.
I didn't find any problems. I thought it was great. It's here in front of me now, right now.
And you said how long was it? 400 meters?
Yeah, we're not going on about this water level now, are we, George? I've got to get some.
I just went on curiosity. I'm just going to compute how much massive water is in there.
Oh, it's about 7 litres? Maybe no. 0.7 of a litre. 0.7 litres. I don't know. I think Spot On's had 7 litres. I know mine's a lot less. You don't think the size of the column matters, do you? For water pressure, George?
Oh, you mean the vertical riser?
I mean the size of the column.
What do you mean size of the column?
For hydrostatics.
You're saying the vertical riser on the ends.
I'm saying, yeah, the size of the column, right?
That doesn't matter that much.
No.
Okay, whatever. I'll just have to take your word for it. I'm just not convinced.
You wait till you see the test, George. It's genius. Shared straight line segments.
Voice is going haywire again.
Yeah, we could. Do you want us to walk you through the test sometime, George? I'm going to have to go and get some kit now because it's 3:30 in the morning.
Yeah.
For us.
Get some sleep.
Yeah. Well, pop round again and I'll run you over the test.
Okay.
All right.
Good night.
Thanks for popping round. Catch you later, guys. I've got to go and get some sleep.
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.